me.
All right. So, now that we've talked about our Wheaties, we're going to be doing something fun this week. We're not going to be doing any coding this week. Well, I guess you could count what we're doing as coding. Not really. It's more configuring. We'll be writing configuration files. We'll be editing a little bit of our code, but mostly just for configuration purposes. And so that's what we'll be doing this week. So there's a whole area of software engineering that's kind of become a thing in the last, I would probably say, 5 years. And you might have heard it a little bit before then, but it's called DevOps, right? Developer operations or deployment engineering, things like that. A lot of engineers who are not originally software oriented tend to like to get into DevOps. And the reason is because it's a very systems oriented sort of thing. And DevOps encompasses all of the things that are not code, but how do systems run up in the cloud? How do systems run down in vehicles? How do IoT and all that kind of stuff? And so DevOps, you can get paid a lot of money to do DevOps. Actually, it's one of the higher paid titles, or at least job descriptions, not titles, job descriptions in software, in the whole HR stack of software. But when it comes right down to it, DevOps is a lot like IT. The networking guy, and a lot like security guys. you your boss is always, if everything deployment wise is going really well, they always ask, why are we paying you? And then if everything goes wrong, they say, why are we paying you? So there's never actually a good position to be in when you're in DevOps. That's just the nature of the game. So you kind of have to live with that reality. But there's a reason why you're paid a lot, and that's reason is because you are on call all the time. And so you get that call at 2 a.m. that says, our website's down, or the entire service is down, or none of our vehicles can report to the cloud for our telemetry. That's on you to fix. You got to fix it fast. So um, there's a lot of fire drills, a lot of hurry up, and then of course there's a lot of hurry up and wait too, because you have to wait on developers to fix bugs so that you can then deploy them. So there's a whole thing around DevOps. So this week we are going to take the code that we've been writing over the last 8 weeks and all the stuff that we've done, and including Docker. We're going to do a lot of Docker tonight. All of that kind of stuff, and we're going to get it up in the cloud. And we're going to do it so that everyone in the world, all over the world, all of us who are all over the world, can access it in one place. So that's what we're doing tonight. The big thing about DevOps is you have to have the best developer deployment operations and development operations that I've heard, or the best operators, I guess, DevOps engineers, are the ones that think in systems, because a lot of this is about communications and interfacing, and how do you get systems to talk, and how do you configure things in order to be really consistent and really work together nicely. So we have to really think about what our system is, right? Before we even start to talk about all the tools. We're getting a lot of lingo thrown out here, as usual. A lot of tools. We're going to be using a lot of services. And I'll try to conceptualize it more to an abstract, generalized kind of concepts, but we're going to have to use a lot of products in order to do this, because that's just the nature of the game. So we're going to really get into that. So when we start at the highest level, what do we got? Well, we've got a few databases, right? So I'm thinking from the top down, from a stack top down. So from that perspective, we have our databases. What are our three databases? I'll let you guys. You've been doing this long enough now that this should be second nature.
MySQL,
I
Redis,
told
MySQL. What do we got?
Redis and Mongo.
Redis and Mongo. So we got three databases that we're going to have to somehow deploy. Then we have our backend that we've been talking about, or our server, right? or what we kind of called cloud. What else we got?
So with Sumo,
We do have Sumo, so we won't actually deploy that tonight, but we got Sumo, and that's we'll actually get to that in a couple weeks when we actually do optimization. But we'll say Sumo right now is down in the embedded domain, right? So we have to worry about what's going to go on there. What else we got to deploy?
front end.
We got our front end. We got our front end over here, and that's separate from our back end, right? And our front end, I still draw it up here on the same level as the back end because it still requires a server, right? The front end actually does run on the client side. If this is the client, actually, I'm going to switch these. I'm going to say embedded over here. And I'm going to be more consistent with the diagrams we've drawn up so far. And so this is our, right, this is our desktop, our mobile apps, right? And then we've also got, you know, everything else. And then we've got our front end, which deploys down our web app down to the client. So this is our client domain. What else do we got?
Got the Yep, that's exactly what I was going to say. The broker.
Our MQTT, which is a whole nother server, right? It's a broker. Do we have anything else?
So React is a part of front end, or
yeah, React is the framework library that we use for front end. I don't think we have anything else, do we? I don't think so. So we got basically all of these pieces, and all of these pieces live up in the cloud, right? These are all in the cloud. The embedded domain is down on the street, and the client domain is wherever the hell the client domain is at that time. And so in order to really think about how this is going to work, we need to figure about address, right? Where do these people, specifically clients and embedded for that matter, how do they communicate with the cloud? So far we've always been talking about the local host.
yes,
That's our local computer, right? And different ports. But we know that all of the websites we visit are not local hosts. They couldn't be. They're up in the cloud. So we actually have a domain name. And so we're going to have to get a domain name. And we're going to have to point that domain name to our cloud. And there's a couple of different ways we're going to do it. We're going to start with the first way. And that is we're going to boot up a droplet, a server in the cloud, one box, a machine, a virtual machine on DigitalOcean. You could do the same thing with GCP, AWS. And that's going to give us an IP address, a public IP address. And that public IP address we can point anything to. Specifically, we're going to point a domain name to it. Now, I'll challenge you guys. What port do browsers and everyone else that's communicating with the backend, what port do they expect it to be on?
80.
What's that?
80
80. Kind of.
or 443 if it is.
443, right? Because we're encrypted. SSL, right, or TLS. So yes, but if you think about it, our backend is not on port 443 or 80. It's on what?
3064.
3064.
One is 9500 and
Yeah.
5500.
These are all on different ports, right? Specific, our backend, which it takes the brunt of it, is on what, 8500, 8000, something like that.
9500, I think.
9500. Okay, so our backend is on 9500. This MQTT is on like 1886, right? For WebSockets, 1885 for MQTT. Our front end is on 3,000. I think Arif said that, or 5,000, something like that. So you got all these different ports. But the problem is we need our domain basically to share, we need all these services to share one domain name. And we know that one IP address you cannot have multiple services run on multiple ports. That's like the big rule, right? Unless you can somehow convince IBM to share their patent. So really what it comes down to is that we're going to have to deploy another piece to this puzzle right here at the edge of the cloud. Sometimes this piece is usually referred to as a load balancer, but it actually serves two purposes. The first purpose, of course, is load balancing. So if you have a lot of embedded devices or you have a lot of clients connecting, this load balancer can spin up multiple versions of this configuration, right? And then it can balance the load across any number of these what we call horizontally scaled services. But we can also use it as a reverse proxy. Now we all probably know what the word proxy means. It's when I say, I'm telling you by proxy or something along those lines. What we're saying is we're acting in the place of somebody. And so when we say it's a reverse proxy, what we're actually saying is when the embedded domain or a vehicle communicates up, we're going to route, and it communicates up to our example domain, example.com domain. We're going to route that through according to what service it hits. And we're going to specifically separate them by subdomain. So this might be mqtt.example.com or api.example.com, right? And then we know that api.example.com will go to 9500. And MQTT or WS for WebSockets will go to 1886, specifically this MQTT over here, right? And then when you just hit example.com, you want that to be conventionally just the front end that anyone can go to. That will hit the front end at 3000. And so we're going to use a tool, something called a product, open source, called Nginx. Nginx runs probably 60 to 70% of the internet. It's a load balancer. Very, very popular. There's a few others called HaProxy that's popular. There's one that we've been using recently, but actually as of yesterday ran into some problems with it, called Caddy. So we ended up falling back to Nginx. There's a couple of others. Traffic is another one. So they serve a lot of purposes, and we also do SSL termination there. We'll talk about that a little bit later. But this guy is actually going to, this load balancer, this Nginx is going to serve our SSL, TLS, or really routed to 443, right? And all that kind of good stuff. And it's going to act as that gateway into all of our services. So this is really going to be our system, this diagram that you're looking at here. So this is our system. The other thing is all of these guys communicate with these databases. And in fact, I kind of drew that wrong. MQTT communicates with Redis, actually, right? But to maintain that persistence in order to scale horizontally. But in the end, these databases, you typically only deploy one version of them. And then these databases are designed to scale horizontally also amongst themselves. And so we'll talk a little bit about managed databases, things like that. Today, we're only going to worry about our Docker containers, just like we've been using the databases in Docker. So we're going to deploy those. But from this perspective, this is all going to be in one droplet or a virtual machine. All right, so any questions with that before we actually dive in and do this? I don't know how much we're going to get done tonight. This is, there's a lot of stuff to get done.
I just have one question about the Nginx, because I think you had mentioned that before. Is that so in that, you said that it's possible to do it, but IBM holds the patent. So you use Nginx because we don't have essentially we can't violate the patent to do it, not because we're not capable of doing it.
Yeah, we're capable of doing it. It's also conventional. You would need special hardware to do it. You'd also need some switching. You need a lot of different stuff to go into it. And frankly, I'm not sure what advantage you would get. Because you do get 65,000 plus ports available to be used. It's questionable, how much you actually need that. Because these, also from an HTTP perspective, you can think, like, what's the point in switching, right? Or like, you're constantly opening and closing these, right? Because it's a very call and response sort of protocol, and so you're always opening and closing and freeing up ports as you're going. So there's really never been a need to introduce that level of complexity in trying to say, hey, can I share this port with another service, or those types of things.
This structure is likely to stay this way for a while.
If not until we somehow structurally change computing.
So even when the patent expires, it's still logical to do this way.
And that was actually kind of a joke when I said about the patent. It's not exactly. That's what everyone always says. The IBM holds the patent to do it. It's more of a joke than anything. I don't think that's enforceable, honestly. But at this point, I don't care who it is. We don't do it because it's so complex then at that point, and there's no real reason to do it. But you'll see them talk about IBM every so often and different things on the web, and the patents that are being held and all that kind of stuff. But it may have already expired. Who knows? I don't really know much about it. All right. So
we have all the three databases on a separate container and the rest in one container. Is that right?
Nope. We are going to separate each one of them into a container.
Okay.
Yep. They're all going to be in a container. And in fact, this front end, we're not even going to put in a container. We're going to deploy it separately using another service. We're also at the very end. Hopefully, we'll get there. I think we'll be able to get there tonight. We got 3 hours to do this. We will actually set it up so that when you'll start seeing the power of Git here. We're going to tie everything together. Imagine a tool chain, a pipeline, what we call a pipeline, a deployment pipeline, where you can push your changes onto the master branch and the entire system automatically deploys. We're going to do that tonight. We're going to hook all these things together, and that's what we call CI/CD, continuous integration, continuous deployment. And that's a very popular thing and there's massive products that are out there on Azure, AWS, GCP, and all these different tools that will automate all of that for you. We're going to use GitLab runners, and a few other tools like Netlify for our front end to do that for us. So you'll kind of see it, but there's by no means is the only tool that we're using. We use tons of different tools also. The ones I picked tonight are the ones that are probably the easiest and quickest to use. We tend to use the easiest and quickest things, but when you go to production, they may not be what you want to use. Like really serious enterprise production, you may want to actually use something like CloudForm or something along those lines, like with AWS. And those tools. So, but the fact that you're going to be exposed to this tonight and the tools that we use, they all work the exact same. It's just a matter of how do you configure them. Some of them have slightly different hooks, or some work better with certain products, things like that. But they all tend to work exactly the same from a pipeline and hook perspective. So, all right. So yes, we're gonna do each one of them. But before we go crazy here. We gotta go to DigitalOcean, and I'm gonna set up a new virtual machine. So I'm gonna do this all from scratch. So this is what we go through. I mentioned it before when the Modesta Technicity guys get together and we say we're gonna do deployment today. This is what we do, pretty much. This you're gonna see it. So so we like DigitalOcean, and the only reason we like DigitalOcean is because DigitalOcean is a really nice stepping stone to the bigger boy clouds. And what I mean by that is DigitalOcean provides a really nice, quick way to deploy onto a virtual machine. I wouldn't necessarily recommend doing this if you're looking at enterprise or if you go work in a big company. I would not mention DigitalOcean other than from a development perspective. The reason is because not because DigitalOcean's not good. We actually use it for some production systems, and it's worked out really well for us. But those are for startups. It hasn't quite made its way into, and it probably will never make its way into the top three, which are AWS, top four, AWS, Azure,
Is
GCP, and anyone know the fourth one?
cloud? I,
Anyone know the
um,
fourth one?
Google
Oracle.
Cloud?
Oracle. Oracle has a cloud. Big, right? And so no one ever got fired for hiring GE, right, or IBM or Oracle for that matter, right? I mean, so it's the same kind of thing. Um, so DigitalOcean's been good. It's just really quick. It's also very cheap. It's also very predictable in price. That's why we use DigitalOcean for development. Um, Most of the time, we'll move off of and move into like moving on to AWS or I like GCP. GCP is great. We'll talk about that in a couple or like next week. All the different tools for machine learning and everything that Google provides from a managed service perspective. We'll walk through their dashboards and stuff like that. But today we're going to focus on it. So I'm going to create what DigitalOcean calls a droplet. It's just a virtual machine. That's their product name for a virtual machine. We're going to use Ubuntu, right? We've been using all Ubuntu, right, in our Docker container. So we're going to use an Ubuntu base for our computer. This is just like you booting up your Windows machine every day. That we're just booting up a Linux machine. That's all we're doing. Basic, you can also see we have a couple of different dedicated options, like if you want general purpose, dedicated CPU, memory optimized. These all come with different prices, right? You can kind of see that. They get pretty expensive if you want specific things, depending on your workloads or those types of things. We're just going to do basic. And I'm going to go with the $10 a month. You could probably get by with 5, but you're pretty much hitting that memory limit because you only have 1 gig of memory.
Are you expecting us to be able to see the DigitalOcean screen?
Oh, shoot. Sorry, guys. Why didn't you guys talk to me before? You guys are silent.
We're just so fascinated with what you're saying, BJ.
Right. Yeah, right.
That little crayon picture that you drew was pretty good too.
Yeah, because we really like that.
You guys were just enjoying the crayon picture. All right, so you got DigitalOcean here. Your basic, your general purpose memory optimized. Some of you may have already clicked through here because we went through this like on office hours 1 week or something as an option for deployment for your own dev environments if you didn't have it. Then you can choose your region. Regions get to be really important when you're talking about global scale or you're talking about latency or timing and stuff. The closer something is to another thing, obviously the faster it's going to be. So there are strategies to get that. We're going to pick New York because that's the closest to me right now. Areve, probably San Francisco would be good for you. And Beth Ann, Toronto, maybe. So actually you're probably closer to New York than Toronto is. So, and then VPC is virtual private networking. As of, I think, last week, they're actually requiring VPCs for every droplet, and that's fine. It's really just a way to put that little firewall around all of your droplets. So if you have multiple droplets, particularly if you're doing multiple deployments and everything and horizontally scaling across resources, they're all within the same security grouping. We're not going to worry about that right now. You can turn that kind of stuff on. And then we can also add an SSH key. We're going to add an SSH key, but I already have my SSH keys put in here. Now, when we talk, what are SSH keys? Well, SSH, secure socket. What secure socket? What does SSH stand for? I'm blanking.
It's like a shell, isn't it?
Secure shell, right? SSH.
Yeah.
So secure shell. It's cryptographic basis and it basically takes the place of username and password. It's based in cryptography, so they just use certificates, public and private key certificates, which we've talked about before. Actually, the same type of exchange as you would do with to get that HTTPS, at least the initial negotiation. And so we're going to use a SSH key here. And you might ask, well, how do I get an SSH key? Well,
Yep.
You might have done this actually, or fought with this at some point. There is
Yeah, GitHub. We generated something for GitHub. Is that same which is SSH or different one?
no, that's the same thing. That
Yeah.
that is actually an SSH key. So if you're using SSH for GitHub or GitLab, then this is the exact same thing. So you can generate your own key. You can do SSH keygen. What is it? SSH keygen, I think. Yep, keygen, and you could generate any kind. Right, I'm just going to do the standard one, which is RSA, and then it will generate a new key and all these kind of things. I already have a key um, in, saved, so and they're always saved in the .ssh folder. Now, for you Windows users, it won't be right on the PowerShell. You're going to have to go into Git Bash, but in Git Bash, you can do this exact same command, and we'll look in there. You'll notice I got a bunch of different public keys and private keys in there. I'm going to be using, I think I'm going to be using this one, which that looks somewhat public keys look like that. Just a random, not random, it's cryptographic string. You can save them and do all this kind of stuff. I already have loaded them in, but if you didn't, you can create a new SSH key, and you're going to put your public key in here, not your private key, because your private key is what you use in order to authenticate. That's derived from your public key. So when you do an SSH keygen, it's going to create two keys, a public key and a private key. You're going to provide everyone a public key. So everyone, that's a public thing. You can feel free to pass that out. Doesn't matter. If anything, it just verifies your identity. So it's only your private key can actually be used in pair with that public key in order to give you a good, basically, seal, right? So you would put your public key in here, name it, and then it'll always give you directions. I'm going to use this public key, right, that I've just showed you, and I just want one droplet, and I'm going to just say FSSE. Let's just do FSSE. And I'm going to create the droplet. I don't need any of the other stuff right now. I'm going to create it. And there we go. It's creating. And it'll take a little bit of time.
Let me just mention something that once you have an account with these guys, they actually charge you by the minute, or actually by the second that your server is up and running. So you can get up like BJ's doing and turn on the $10 a month server and use it for a couple hours and shut the thing down or destroy it, and you'll only pay just a little bit, and so anytime you want to do it, you just get up there and start yourself a whole new server.
That's right. One of the things
with it, destroy it, and
yep,
do it the next time you're up.
That's one of the things we like about DigitalOcean is they cap it at certain amounts. Sometimes it's hard to tell with an AWS or a GCP how much they're actually going to charge you. You have to do the calculations. They don't make it that clear all the time. So it's not necessarily a bad thing. I mean, you can do that math pretty easily, but there is an art in calculating your costs when you're talking about managed cloud services. All right, so we got an IP here. That's good. I'm going to do this. So I'm going to edit my my config, my SSH config, and you'll notice I have a bunch in here. But I am going to I'm going to add a block here, and this SSH block just allows me to very easily do the logins. And so I'm going to say FSSE, and I'm going to need to replace my host name with the IP address of this droplet, and I have to change that to root, and then my private key is BJ Yurkovich, not my public key, but my private key, because it's going to check that key. So what DigitalOcean did was it took my public key and installed it into that virtual machine so that now I can use my public key against it. All right, so I'm going to save that. And then I can now say SSH FSSE because I named that config block FSSE, and I can go. The other way I could do it is I could say root at that IP address -I, and I would need to .ssh/BJ Yurkovich private key and use that and connect. And I am now connected to this computer. If you think about it, that's a pretty amazing thing. I just paid $10 and I got access to a full 2 gig computer in the cloud, and I'm connected to it within a minute. It's a pretty cool thing, if you ask me. And so we've got this, and then you've got all your this is Ubuntu. You can see this is your Ubuntu machine. It looks like our inside of our Docker container and all that kind of good stuff, and all that. So here's the thing: we need to. What's next? Well, what's next is that we need to get a domain name, because we need to point our domain name to this droplet. So how do you get a domain name? Well, we're not going to do that here because it actually takes time to propagate. So when you buy a domain name, it's not instantaneous. It'll take a little bit of time to work its way through, but I'll show you kind of the steps here. So we could go to domains.com here, Google. I buy a lot of domains through Google. Sometimes you'll see GoDaddy. See, I have some domains here, that kind of stuff. One of the ones that I bought is Full Stack System Engineering. So fullstackse.com. And Fullstack SE, what I've done is I've actually, we use a service called Cloudflare. You may have heard about Cloudflare. It's like one of the largest internet companies you don't really hear about unless you're in the industry. A lot of the internet, whenever you have those days when the internet goes down for you and like nothing's working, like who knows why, a bunch of services are out, it's most likely Cloudflare is having problems or AWS is having problems. One of the two. It usually comes down to that because they own most of the internet, as it turns out. So Cloudflare is very interesting because Cloudflare itself is a security company, but they manage a lot of different services. So where in my registrar, so when I go buy a domain name, how many of you have bought a domain name? Probably a lot of you, right? Yeah, so you kind of know. You went to GoDaddy, Namecheap, something like that, right? And that's a registrar. And you can go to the DNS zone. So let's pick iOttery here, which is our, we'll go to our DNS, and you'll notice that you could do different things here. But actually what we've done is we've changed the name servers and we've pointed them to Cloudflare. And the reason is we use Cloudflare to actually manage the domain. So the only thing that our registrar, so if this is Google Domains or GoDaddy or Namecheap, whatever, the only thing they do is register your domain. Everything else is done through Cloudflare. And you can do it, you can set it up, and it's a little setting, right, to set it. And so I'm going to log into Cloudflare. Cloudflare's free. You can sign up for an account. And I'm going to sign in, and we've got this here. And I'll log into my account here, and I've already purchased fullstackse.com. fullstackse, and I'll sell it to you for like 50 grand if you want it. It's a pretty popular domain name, and that's a whole market right there. So we got a lot of different things. I've already did the solution because I wanted to make sure that we could get through this. So I already have some records here, but all this is api.fullstackse.com, and I'm pointing them to a droplet. So what do we have to do? Well, we have to actually add a new record, and we're going to point the primary record, so fullstackse, to our droplet. Now, why did I put that @ in there? Because that is it's a convention for no subdomain. It's just fullstackse.com. And what do I put there? Anybody? What do I put for the IP address?
Your droplet IP?
Yep, droplet IP. So I'm going to copy that and paste that in there. And I'm going to go DNS only, not proxy. Cloudflare, sometimes you want to proxy it through because Cloudflare will actually act as a proxy also for you in order to do DDoS mitigation, distributed denial of service attacks, which you might have heard about. things like that. So we're going to do DNS only because we have to actually create some certificates. And when you need to create certificates, you don't want to be proxied through someone else's stuff because it won't work. All right, so we're going to save this. So we got an A record. You'll also notice there's lots of different types of DNS records. Sometimes you hear they're called zones, DNS zones. You can do A records, C names. MX is for mail, for email and stuff. So that's how you manage your email domains. If you've ever set up email domains or anything, you probably suffered through this. So this is one of the oldest things in the internet, are these types of things. So you see a lot of legacy kind of stuff that go through. So we just set up fullstacksc.com that points to our record there. Now, normally, I already had this set up, so normally it can take up to 10 or 12 minutes, usually, from what I've seen, sometimes an hour, sometimes 48 hours to propagate through if it's a brand new setup. So, all the name servers have to work its way through. And the reason you might say, well, why does it take so much time? The internet's like instantaneous. Well, what's actually happening is ISPs all hold their own caching of all these domain listings. And so depending on where you are in the world and how your ISP updates and caches, you actually probably noticed the TTL on this. What is that TTL? It's that time to live. So how many times should should your ISP or the people that are caching the link between your domain name and the IP address, which is cached all over the world in many different places for speed reasons, how often should they check for that? And so I have these all set for 2 minutes because I want to check all the time so that we don't have to wait. Normally, that's actually going to be a performance hit. You don't want that. So if you're never going to change that record, you want to actually put that to be a pretty long time so that those domains never run out.
So something this is the same as the hops or different?
It's a little bit different. It's that initial lookup. So the hops are after that's actually been established, that connection's been established. It's really more of the initial, like, hey, when I in my browser put that domain name in, it uses UDP, not TCP, but UDP to go out to the name servers, the DNS, and ask, all right, for this domain name, what IP address do I need? Then it sends back that IP address, which is actually how denied services work if it's not configured correctly, and it uses that IP address to then do to start that hop process, that IP packet dispersion to the point that you want, that IP address. All right, so what was I going to do? We're done with the registrar completely. We got that. Oh, so let's check it out. Let's fullstacksc.com, and nothing's running. But there's nothing running, right? That droplet doesn't have a server running on it, so I wouldn't expect it to connect to anything, right? So let's do something real quick just to see something. We're going to install Nginx. Now you'll notice that I am using root here. I don't necessarily recommend it. I would create a new user. We usually use webdev user and then use that. I'm going to use root here just for sake of time. So we don't have to configure a new user. Not that it takes a long time, but but that's just, you usually don't want to use the root user on the server. Anyone know why? Anybody? It's because for security reasons. Someone gets into your server and you're on root, they got complete control. Whereas they would need if you create your own user, then you could limit permissions and things more easily. All right, so we've installed that, and you'll notice that if we go to fullstacksc.com now, there's a server, Nginx. It was our load balancer. So we need to now configure this in order to route around, but we still got to set up a bunch of stuff right in our backend to do this. But you can now see that you guys can all visit this too. If you're on your computer, go visit fullstacksc.com. You probably see it, right? That's pretty cool. Worldwide, you can see it now. Maybe not Justin. His eyes.
Since this droplet is Ubuntu server, you're always doing sudo install?
So I did sudo because that's what you should do when you have another user, but because we're root, you don't have to do that.
It's down here already too.
All right, that's good. So yeah, I use sudo. You don't have to because this is a root user, but you would if it wasn't a root user. All right. So, we got full stack SE. So now at this point, I think we're ready to configure our stuff to deploy onto this droplet, right? All right. So I am going to go to GitLab here. We got week 8 office hours. The office hours, JC. It's got our latest front end and stuff on it. Styling.
Yeah, that's the latest.
All right, so I'm going to use this. Let's see here. Now, if you notice, I am not actually opening up a. I am not opening up a development container, right? I am activating my machine, and the reason that I am is because um, we've got. I don't really want. I want to be able to build the images, and I don't want to build Docker images within Docker, right? I want to build them on my host machine because I want to build Docker images in order to make sure that they're going to run on the droplet. So we're not actually ever going to start a development environment tonight. We're going to be doing everything just on our host computer. So I'm gonna git clone here. Week 8 office hours. There we go. And let's see. The first thing that we're gonna have to do is we're gonna have to probably problem is there's so many things we could do right now. Let's create a Docker Compose file. So within our you'll notice that we're going to create our own Docker Compose file. We're going to create it here. We're creating a Docker Compose file in order to deploy on our droplet. So it's going to look like our Docker Compose file that was in our dev container, but not quite. It's going to look a bit different. So I'm going to leave this in here, but for now, I'm going to make a few different things. Actually, no. I'm going to take this one out. We don't need that. We still need MySQL. We're not going to be using any managed database services. We'll talk about those later, but we're still going to use just our Docker containers. Don't recommend that for production. You always want to use a managed service because you don't want to get in the business of managing databases in production. It's a very frustrating thing, plus with replica sets and all that kind of stuff that you need. We'll talk about that later. So we've got, I'm going to say MySQL FSSE deploy. And all this stuff looks fine to me. We're going to leave that the same. This Redis looks fine to me. We can leave that the same. Mongo looks fine. That's all the same. The only thing I'll probably do is I'll just add a different name here to the container names so that they don't conflict with our development containers when I put them locally. It doesn't matter when they go into our droplet because there's no development container in the droplet, but I'm just going to create new names so we can test them out. But we don't need dev anymore, right? Because that's not, instead I'm going to call this app. And when I call it app, I'm going to get rid of this image. And instead, I'm going to pull in I'm going to pull in a few different things. So I'm going to first, I need to tell Docker Compose where the build context is for my app. And when I say app, what is the app? Well, it's cloud, right? That's really what we're talking about. That's the back end. And so I need to make sure that the build context for this Docker is going to be in the cloud folder. And in doing so, I'm going to add a Docker file into my cloud here. And for the Docker file that's in cloud, I am going to pull from node 12 If you remember our Docker back a number of weeks ago, what is that doing? Well, that's pulling a node image from Docker Hub, and we're going to use that as our base image to run our app. Why are we doing that and not Ubuntu? Well, Node is optimized for Node applications, and that's all we want to do, right? Our backend's a relatively straightforward, simple app. It's just a Node application, right? So there's no reason to pull all the other Ubuntu stuff that we had for our development. We were doing that because we wanted all the development tools and everything that came with Ubuntu. We don't need that. All we want, and we want to keep these as small and as tight and compact as possible. And so that's all we need. We're going to do a work directory here. So we're just going to create a new work directory inside of our Docker container, right? And then we're going to copy package star, so package and package lot.json, package lock.json, and we're going to copy it into our current container, right? And this is a build step, so this is on build, and then I'm going to run npm install. So I'm going to just install the dependencies in that were in the package and package lock, and then I'm going to copy the rest of stuff. So if you noticed, I only copied the package.json stuff, and then I npm installed. I didn't copy everything else. Does anyone know why I did that?
Because package.json carries all the dependencies in it. As
It
in,
does. Yep. Any other reason? I mean, you're halfway there. The reason is we do this is because Docker has build stages. And the thing is, your dependencies are not going to change that often. And so what you want to do is you want to minimize the time that it's going to take to build. And what Docker does is smart enough to know if things haven't changed in certain build steps, then it doesn't have to rebuild. And since your dependencies don't change that often, we want to get all that in because that's actually a pretty expensive operation, right? It takes a long time to pull those down and put them in. So we're going to copy that in first, install it, and then we're going to copy the rest of our code, which is just code. It's really, really easy and simple. So, and that's going to be changing the most. So that's why we copy it in next. And so whenever that changes, it's a really quick build. So it only has to build once, right? That's why we do it. So we're going to copy the current directory, meaning everything that's in the cloud folder, into our current directory, our current working directory of the container, that directory. And then we're going to run a command. And what's that command? Well, it's just node and index.js. Pretty simple, right? So that is our Docker file. That's going to run our node app, our cloud node app.
So it's going to use the same ports and all this stuff?
Use the same ports and everything. Because we got Nginx working for us, right? So we don't even, so here's the thing that you've probably noticed. We're really not changing much. In fact, we're trying to change as little as possible because we want to basically run in deployment how we've been running in development. Because the more you can minimize that, the more chances of bugs in production that aren't in development occur. And so you want to minimize as many changes as possible. Now ports, you could argue, well, it's a port. Like, what are the chances of it breaking? Well, that's like a DevOps problem, right? It's like, figure out what ports I'm running on kind of thing, right? Still, when you're doing the full stack like we do, you're going to thank yourself later that you're trying to keep everything as consistent as possible because you spend so much time beating your head on the wall. And probably tonight, guys, I will probably beat my head on the wall a couple times because the thing about DevOps is it's all about the details. Every single little detail, and I'm sure you struggled with the Docker, right? It's all about those tiny little details, like you missed a period somewhere, you missed a port somewhere. And the more of these systems, the more systems you got, the more complicated it gets, and the more things that can go wrong, right? So that's why it's so frustrating. I like it when it works. I hate it while I'm doing it. that's DevOps is amazing. If I'm having a good DevOps day, DevOps is amazing. I love it. I'm going to do it the rest of my life. The minute something goes wrong, nope, never going to do it again. This thing sucks. I hate DevOps. So it's a love-hate relationship with me and DevOps. Same thing with like databasing. All right, so we got our Docker file for cloud. And so we're gonna set our context for cloud and Docker file for Docker file. I'm going to FSSE app and I'm going to say deployments. And it depends on these things, right? Still depends on those. It has to, because it needs the Mongo, Redis, and MySQL. But we don't need all of these things, right? We're going to take those out. We're going to need them for other things, but we don't. We only need 9500 to 9500. We could have also ported 4443 through if we wanted, but that's going to cause a bunch of issues. I'd much rather do that at Nginx and just keep this real straight through, real simple. I'm going to change the node environment to production here because we're going to deployment. And you might ask, wait, what are these environment? Well, these are environment variables, right? We talked about environment variables a few times. I mean, with Sumo, you probably worked with that a little bit. That's all this is. We're just changing the node environment to production. And then we're probably going to be doing a few other things. Let me verify I didn't forget anything. There's a few other things we need. First of all, we need port. We're gonna actually say the port is 9500. You might say, wait, why? You just specified it up here. Well, because you got to tell the application what port to run on, right? And so you have to inject that in. And then there's one other thing, but we'll wait a little bit for that. So the there's a few things we're going to have to do here. So we've got, let's go into configuration. Now I'm in cloud here, right? Now you've noticed probably that there's a few things. Are we in cloud? Yeah. Okay. So there's a few things that we have to worry about here, and that specifically is this port. So there's usually what we want to do, just in case we did change that port, we want to pull it off of the environment, or if it doesn't exist on the environment line as an environment variable, we'll choose by default 9500. So that's what this little syntax is saying, is if port exists as an environment variable, then use that. Otherwise, we'll use 9500. And so I just want to make sure in this that we got our bases covered and that we're configuring it. So if we do change this to 8000, or we have to because of another service, we can always change that. And as long as this uses this backend uses everything, then we're good to go. Same thing down here with MQTT. We will actually, let's do this first. Let's do process.env.mqtt host. Now you might say, what is this process.environment stuff? Like, is that a thing? Well, in Node, process.env is the way to access the environment variables. So process is a built-in, I didn't have to import any library, that's just a built-in Node keyword. It's an object that has a .environment, and then all the environment variables for your system are loaded into this environment as an object key value pair. So we're going to do the host here, and then we also are going to do the port, like that. And we probably should do the username and password too, in case those change. Like this. Like that. All right, so we're starting to really do this stuff, which is good. And then what we got here is we can also do it to the secret and the expiration. On all of our configuration files, I'm not going to do it just to save time here, but for all of our configuration files, we always make them completely configurable from a config file, but we make them configurable from the environment also, so that from a development operations perspective, DevOps perspective, we can specify those and change those around without having to change any code directly. And in fact, if you're separating responsibilities between development and DevOps deployment, you don't want your DevOps people to be changing your code, because frankly, they're probably not going to understand. And so you just want to say, look, I'm always just going to be specifying these environment variables. These are the things you need. So that's kind of where that separation starts to occur. All right, so we got our index.js here, stuff like that. Typically, you also have your database stuff in here. Since we're using just Docker, right? And Docker databases, we're just going to keep that there. But typically, you would pull out your database connection info to here, and in fact, just for completeness, I'll add it there. Just copy and paste it over. That was a lot of code that I just pasted in. It doesn't matter at this point, and we're not going to change it in the actual stuff. But this is basically, hey, MySQL has these configuration, Redis has this configuration, and Mongo has this configuration. So you can kind of see like that's how that would look. And so we typically do that, and then in the actual code, we import configuration, and we just import port, username, password, and use that in your code. So you've abstracted all of those variables, so you're not hard coding specific things. And you might say, wait, where was that again? Well, it's in lib databases, right? And like all these databases, you'll notice that we have these hard coded here. That's where you would import config, and you would put Mongo connection string. If we go back to our configuration, you would use the Mongo connection string instead of this hard coded thing here. It also makes it good so that if you want to reuse it for another project, all you have to do is change your config as opposed to having to dig through your code and all that kind of good stuff. So we're not going to do that to save some time, but that's basically what you're kind of looking at. I'm going to remove this because it's not going to be used. But I wanted to show you briefly that's how your configuration files will start to build up.
And it really is nice that you can find all the environment variables you need in one spot. You're not searching through the entire code base trying to figure out what environment variable is going to flip what, right?
Right, exactly. All right, so we've got that. And it looks like we're good to go. We got our port specified just for completeness. We got our volume specified so we can persist those data. That's really important, especially in production. You want to persist your database. You don't want, when your Docker is shut down, to lose everything. So that's good. There's one more thing that we need to do for deployment, though. Anybody?
Create a Docker
What's that? Anybody? There's one more service. Remember, go back to my crayon drawing. Clayton loved my crayon drawing.
Oh yeah, the red color one.
What was it? I don't know if you'll be able to see this.
Balancer. Load balancer.
You see it? Nope. That's
Balancer.
The load balancer? Nope. Don't need the load balancer. Although you could put Nginx, and in fact, usually you do put Nginx in these configurations. I'm not actually, from a pedagogical standpoint, I want to show you how that works, but oftentimes you will. The other thing, by putting Nginx in here, you actually end up putting a loop. You'll have some dependencies that won't work, so you got to do some special weird configuration stuff. I'll talk about that later.
You need your front end, don't you?
Front end, if we were using it here, we're going to actually use a managed service to deploy our front end, so we don't actually have to use this. That was a good thought. What else? What other service? I think we've said everything except the one that we need. MQTT. Yeah, exactly. So we need to define MQTT as a service. So here's MQTT, and we're going to do the same thing as we're doing here. We have our build context and everything. As opposed to the cloud, our build context should be our MQTT broker. I think that's what the folder is called, right? Yep, there it is. And we will create a Docker file in our broker here. And the Docker file, anyone know what the Docker file is going to look like? Anybody? As it turns out, it looks identical to the cloud Docker file.
It's a node.
It's just a node app, right? And in fact, I think it looks identical. Let's go through it just to make sure. Node 12, that's good. Work directory, that's fine. Package.json, that's what we need to install that, right? npm install it, copy the code, and run index.js. Let's just verify that index.js is the main. Yep, there it is. Good to go. So Dockerfile is the same. So that makes life a little bit easier here. Oops, why did I put that?
So you want a Docker container for every single one of these, right? You want to separate them out.
Yep, each
that-
service gets their own container.
Okay.
Man. All right. So we have MQTT, and then let me see here. Yeah, every service gets its own container. Container name. And the container name is going to be, let's do MQTT FSSE deployment. And then what do we got? We got some ports. What ports do we need? Anybody?
This is
1885, 1885, right?
Yep, 1885. We'll port that through. And what? We actually have two, right? 1886. It might not be, that's probably a little bit fuzzy for a lot of people, right? Why do we have two? One of them is MQTT, remember, and one of them is WebSockets. The reason we use WebSockets is still MQTT. It's just MQTT over WebSockets. The reason we use WebSockets is because the browser cannot natively support MQTT. So it needs to use WebSockets to connect. So that's why we use 1886 for WebSockets. And then, let me see here. What else do we got? We have some dependencies. What does it depend on? Anybody? Depends on Redis, right? And then it's going to also have an environment variable. And the environment variable is the MQTT gateway host. And what is the MQTT gateway host? Why do we need that? Think about what the broker's doing. This is something that JC did.
Publish.
The publish, right? Well, from the gateway, it needs that. So the gateway is going to need it. But why does the MQTT broker need the gateway address?
We can need to receive information from readies.
No. It needs to authenticate, right? It needs to authorize the users to access the broker, right? So it's going to it has to make HTTP calls to the gateway, right? And then the gateway also has to connect to MQTT. So we actually have a bit of a circular loop here. These guys have to connect to each other. So what we're going to do is we're going to say the MQTT gateway host is linked to app here. And then what we're going to say for app is we're not going to actually make the app depend. Maybe we will make the app depend on MQTT. That's probably not going to work. No, that's all right. We'll make that work. So what we'll do here is we will we'll say that this guy, the app, is dependent upon MQTT. But you'll notice that this is just app because it needs to communicate right back and forth. But really, Yeah, that's gonna be a bug. Sorry. We'll deal with that later. We're not gonna actually make MQTT depend on this. What we're gonna do is we're gonna make app dependent upon MQTT. And then here we're gonna have to add a MQTT host, and we're gonna have to put some URL, right? Some MQTT URL, but we haven't defined that yet because that's the fullstackse.com URL. So we're gonna have to figure that out so that the app can communicate with the MQTT gateway out the internet through Nginx. And the reason we do that is to minimize the circular logic thing. Now we're going to fix this in a little bit, and there's a whole discussion about how do you get over dependencies, and there's some sophisticated Docker Compose stuff you can do with linking and all those different things. I'm not going to confuse the issue right now. We're just going to get them to communicate with each other kind of through the internet, as opposed to trying to do it all within Docker Compose. There is a way, and I'll show you, but let's just do it kind of the easy, natural way first. So we've got this. We don't need these anymore. That's looking good.
You need to mount it on the Droplet server now. Would you bind it or?
Yeah, we definitely need to get it to the Droplet server. That's for sure. We'll get there.
So my question was, would you mount it there? I mean, do you need to put the configuration here in Docker Compose YAML file as to how you will be where you will be mounting it?
What do you mean mounting? I guess I'm not quite sure what you mean by mounting. You mean like actually like where you? Yeah, I guess I'm not sure. Let me continue, and I think your question will be answered. So basically what we've got is, so I think we're generally okay here. Got all this kind of good stuff. We got the MQTT gateway host. We're going to have to do this. In fact, we kind of know what that's going to be. That's going to be API.fullstackse.com. Now I'm making some assumptions here, right? I haven't quite said this. So this is a subdomain, right, to FullStackSE. So now that we've kind of figured this out, like all these different connections that we've got to make, let's go back to our DNS and start to make these. So we have our fullstackse.com. That's our front end. But we're also going to have to add this API, and it's got to go to our back end. So this is going to be api.fullstackse.com, right? We're also going to need MQTT, also pointed back here. And then we also need WebSockets, WSS, pointed to that. Now, they're all pointed to the same place, right? All port 443 or whatever. The reason is because we got Nginx going to be working for us, but we need to configure that. All right, and all right. Do we have all of our things? We got FullStackSE, API, MQTT, WSS. I think we're good. I'm going to change this to just WSMQTT, just so it's very clear what we're doing. So this is WSMQTT, WebSockets MQTT, 186, right? We're going to route 186 through that. We could use 185, API FullStackSE. All right, so we got that. So if we know this is WSMQTT.com, then we can go over here and we can say, all right, we know that this is going to be ws-mqtt.fullstack FSSE.com, because this MQTT host is the MQTT, right, address, whereas this MQTT gateway host is the API.fullstackse.com, because this API points to app. That's our backend, right? That's our server. All right, let's just make sure we've got these MQTT gateway host environment variables set here. So we're going to go here. Let's look in here a little bit in configuration where I'm in the MQTT broker. Right here. Is that the right? So gateway host. So, and it's port 9500. We actually don't want that to be 9500. Gateway port's actually going to be 443, but I'm not too worried about that. I just won't set that. That'll work. The other thing you'll notice here is that by doing this, your development's going to be the same, right? Your development experience will be the same because you just won't set these locally when you're developing. But so you'll be able to use localhost and you don't have to change anything. There's no special variables you have to change just for development. But then you can also always specify these. This will always be different in deployment, right? Always. But you don't have to worry about that. That's all done by setting a simple environment variable. And so it's more of a configuration error as opposed to a coding error or complexity in always changing back and forth when you're trying to go between things and just waste time. Okay, so I think we're good there. Let's see. I think there's a few other things that we got to worry about. Yeah. So we actually introduced these here. So we got to find out where this is actually occurring, right? In the code, because we got to go change that. They don't just magically happen in the code. And so we got to go over here, and you'll notice JC actually hard coded this stuff in here. And so what we really want to do is we want to now import config dot mqtt dot host. And then here we want to do config dot mqtt dot port. This is for the gateway. Gateway.host, config.gateway.port. All right, that's good. And then we could also have done username or password, which you would want to do in deployment because you want to change those so that your code and stuff isn't, you don't hard code that stuff. I'm not going to do that to save time here. But you always want to do those key stores and all that kind of stuff. And then let's see. All right. I'm feeling okay about this. We're gonna have some issues, I think. Yeah, we're gonna have some issues, but we're gonna be able to get most of the way there. So why don't we take a break before we go any further, and then after the break, we're going to we're going to attack that droplet. We're going to deploy this on the droplet. We're going to do that mounting sonnet that I think you're referring to, but we're going to start using Git to do that. And then yeah. So why don't we take a 5 to 10 minute break? Let's do a 5-minute break, and then come back and look at some stuff here and make sure that that we're going to be okay too. All right, I'll see you guys back here in 5 minutes.
Hey BJ,
Yeah.
you got a sec? If you got a sec, you want to put my SSH key into that droplet? I can work on setting up an alters file to load up different accounts for everybody once we get this thing deployed. I don't know if we'll have time for that, but
I mean, if you want to give me your, I don't know. What do you mean different? Oh, you mean all the users in the database?
yeah, I would just grab a alters file, prep it, and then we can apply it once everything's deployed so that everybody has an account, give them initial passwords, and then they can use those credentials to load up their own vehicles.
That could be cool. Yeah, sure. Can you give me your key?
Yeah.
I'm gonna have that. All right, you should be good.
All right, I'm in.
Cool. Yeah, start doing the ultras file, but we got to deploy that first. All right, is everyone back? Still missing some faces, so we'll wait a little bit. All right. Looks like we're just missing Beth Ann. And JT's decided not to show his face anymore, so. Give Beth Ann one more second. All right, so far, I don't think anything's been too crazy, right? I think I promised no coding, right? We haven't really coded yet. All we did was change some configuration parameters, so that's good. This is where things get a little bit crazy. This is where we're starting here. Not really crazy. They get really confusing because of all the different which ways things can go, and where things are communicating from and to, especially when we talk about CI/CD. So this will get good. All right, so what we have is I'm back now. You guys can see my screen. I'm back now, and I've logged in. Right, I haven't logged out. I'm in this droplet. This is our DigitalOcean droplet at this place right here. We got all our subdomains pointed to it. Right. We've got it running with Nginx, so that's good. And so let's do some stuff. So the first thing we have to do, and this Sonat I think is going to answer your question on how do we get the code to this droplet. Anyone have an idea? How do we get the code to this droplet? How do we get those Docker Compose files? How do we get that stuff to the droplet?
So install Docker on the virtual machine.
All right, so we can sudo docker, although I'm root, so I don't really have to do this, or sudo, but apt install, and I am just going to go I am going to sudo apt update. I'm going to go look at install Docker Ubuntu. So install Docker for Linux, and I'm just going to go look down here, and I've got a bunch of different things here. I need Ubuntu. Whatever. Oh. the one thing about I just want to install Docker engine. That's all. That's all I care about. There it is. Debian, Ubuntu. That's what I want. All right, so we want to do this. It's just a bunch of. Oh, can't do that yet. All right, nothing's on there, so that's good. So we're going to sudo apt install all the different dependencies that we need. I already did the update, so doing that. So we got that. We got to add the GPG key to make sure we got the right thing. And then what we have to do is we have to install the AMD 64. That's the platform we're on. And then as that's installing, we need to update it again after that's done. Get all the latest updates from the registry we added, and then install Docker. All right, cool. And then we also need one more thing. We need Docker Compose, right? Let's install that. As long as that's relatively straightforward, you just have to do a curl here, and then we're going to change some permissions. It says to do. And then just make sure we've got the linking in, the symlink. We are good to go. Hopefully. Docker Compose. Does that work? Yep. So we're good to go. We do Docker PS. We can do that too. All right. So we have Docker installed. All right. So we got Docker installed. So good call on that, Ariv. One down. How do we get the code? How do we get Docker Compose? I mean, how do we actually get our configuration files and our code?
VS Code.
VS Code on here? No way, man. We're not putting VS Code up here. Anybody? We're using Git. Remember, we have content version. We got it all at our disposal. So we're going to have to create a new repo. So we have to pull it down. So I'm going to create a new project here. I'm going to create week 9. So I follow our convention here as a dash. All right, new project. I'm going to create a new project, week 9. I'm going to create a project. So that's good. And I'm going to go back and I'm going to remove. So remember, so I went back. This is our code now. Remember, I pulled down week 8's office hours. So Justin's the latest code, right? What we need to do is we need to remove the .git folder because we need to now push this up as week 9. In fact, every single week, you know how you have the new week's code? I do this every single week to the previous weeks. That's how it builds on itself. So we do this every week. So we're going to remove the current Git. So now we've ripped out the fact that it knows anything about the week 8 office hours. The folder's still named that, but it doesn't know that. I'm going to say git init, create a new Git repository. I'm going to say git remote add origin, and I'm going to add this guy's URL. Say git add, git commit, and push. And it's all up there. Look at that. So now it's all right here. We can verify, yep, we got our Docker Compose here, so that's good. It's all the thing we just did, right? And now we can pull it down here on Git. Or on our droplet, right? That's kind of the beauty of Git. So one of the really nice things about Git. Now, there is one thing that we're going to want to do that's a little bit more complicated than just pulling it down here. Now, if I did this, if I said, git clone that, it's going to ask me for a username and password. You could put yours in if you want. What if you have multiple people working on this? You don't really want to do that, right? And most of the time we do have multiple people working on it. So instead, what if we gave this guy, the droplet, credentials to this Git account, to this specific repo. And we can do that. And we can do that by creating an SSH key for it. So we're going to do that. We're going to create an SSH key, and let's see here. I am going to create, I'm going to go to .ssh. Notice our authorized keys are in there. That's got my key, and then I added Justin's key, actually, JC's key, so you could do some stuff on this here. But I'm going to do that SSH keygen command. And I'm going to create an ED25519 key. It's a specific type of crypto signing. And it'll ask me a few questions. Enter the file in which you want to save the key. I'll save it under root /.ssh /GitLab, because that's what I want to save it as. And that will create, if you'll notice, that will create a public key called GitLab, GitLab.pub, and a private key .GitLab. What do those look like? Well, the GitLab.pub looks like this SSH ED25519, the same thing I showed you with my SSH key. And then what does the private key look like? Well, it looks like a begin OpenSSH private key, a signed key, end, right? That we don't want to share anywhere. In fact, Zoom can now look at our private key, and if someone wanted to type that out, they could, right? So we got that, and so what we need is we need to add this public key to GitLab. We're going to go over here to our GitLab content. And we got members here. We got settings. I'm going to go settings. I'm going to go to repository, and I'm going to go to deploy keys here. So GitLab has a nice, so I'm in the settings of just this repository. It's got a nice little thing here where it says deploy keys, and I can add, I can do our prod server droplet, and I can paste my public key there. And I don't want write access. I don't want to be able to write from this server. I just want to be able to read stuff. I just want to be able to get the code. So I'm going to add the key. And there it is. And so what that means is that I should be able to do this. Now, I'm going to do a few other things. I'm going to eval the key.
What is the username for this one?
Root. I don't know why that didn't work. And then I want to add everything in my .ssh folder. So I want to add that .gitlab key. Those are just some commands that you do to make sure that it's added to the keychain of the droplet. And then what we can do is we can go back to our repository, week 9 repo, and instead of cloning the HTTPS, we can now clone the SSH. You might have been wondering what that was. So git clone, and hopefully this works. So let's git clone that, and we shouldn't have to put a username or password in. Darn it. I'm sorry, git clone that, yeah. Looks like permission denied. So we got to figure out why the permission was denied there. You see anything, JC? What did I miss?
Where did you put the public key? You may have to. Did you add the identity already?
I thought I did, but maybe the SSH add didn't quite pick that up.
So do we need to configure this new key?
There it worked. I needed to add the SSH key. So if you notice what I did there, I just said SSH add the GitLab key that I made, the private key. And I guess SSH add did not actually do what I thought it was going to do. It was going to add all the keys in that .ssh folder. I had to explicitly add that GitLab. And so once I added it, now I was able to pull down that week 9 folder. And now I have cd space week 9. I got all my code on the GitLab. And oh, guess what? When we go to CI/CD, we can automate the process now. We don't have to enter a username or password. That's the other reason, because that takes an actual manual intervention. Now with this GitLab SSH key, it's just as secure because it's just credentials for this specific computer, for this specific VM, and it doesn't require any intervention. So we've got all this. We now have a Docker Compose file, and so we can do Docker or sudo Docker Compose up. And when we do that, sudo Docker Compose up, that will build and bring it up, or we can just do build. And I'm just going to do build here. We're going to build all of that stuff. So it's going to pull down, it's pulling down all that stuff, right? It's pulling down the node containers, the base containers. It's pulling down Redis. It's pulling down Mongo. It's pulling down MySQL. Everything that we have listed, all these images down in this container, or in the Docker Compose file. So that's going to take a little bit of time, not too much here. It should only have to do it once, so that's good. And then once it builds, hopefully it will build without problems. Once it does that, then we'll be able to do the configuration. So while that builds, let's talk a little bit about Nginx.
BJ, can I just ask you before you do that? So you had put in the, I think the cloud, the cloud share, was that what it was? To update it. How often will it go? If you go and update that code, will it automatically update it to this? Like, will it go and check, or do you have to go through this process if you update the code?
We haven't done CI/CD yet. You're gonna have to manually do it. So if you update the code, let's say we update something over here, we're gonna have to push it to GitLab, and we're gonna have to pull it here. Now, at the end of class today, we're going to hopefully have time. We will implement it so that it will automatically do everything. So all you have to do is push it here, and it'll automatically deploy all the way through. It's all using GitLab too. All right, so that actually was very fast, which is good. One thing I wanted to mention before we go crazy here is that, we added all of these, API, MQTT subdomains. And so if we do this over here, we should be able to go api.fullstacksc.com, but that also points to Nginx. Everything is pointing to Nginx right now, right? We don't really want, we want it to point to Nginx, but we need to route that through to all the other things behind it, right? So keep that in mind as we go. But we haven't even booted anything up behind it. So even if we configured Nginx right now, thered be nothing behind to point it to, right? So let's actually get it running, and then we'll configure Nginx. So we could do Docker Compose up. And up just means to bring all the services up. So it's going to start those Docker containers, each individual one, and hopefully it'll work. So we've got that. Oh, nice. It didn't quite pull all of it, I guess. Nice. All right. So it looks like it's pulling Redis now. Mongo? No, it's pulling Mongo here. And then creating deployments. We're creating MQTT. Oh man, something failed. No. No, it looks like we're okay. All right, so I'm going to stop those. Now, if you notice what I did was I said Docker compose up. And what that did was it was a blocking function. So it just kept running, right? What I want to do is I want to run all those containers in the background and then still be able to do stuff. So I'm going to do a Docker compose up -d. -d is detach, right? It's the same command as we do in Docker. We're going to run that. It's going to bring all those guys up. Done, done, done. It's going to run all those. And then we can say Docker PS and see if they're all running. Looks like they're all running. Well, no. We got app. The one that's not running is MQTT. So for some reason, MQTT is not running. But fortunately, the rest are. So I wonder what's wrong with that MQTT. It says it cannot find module cloud configuration. Oh, looks like we got an error there. I think that happened because I auto imported. Remember when I went down here and I said configuration dot? I let the IDE import something, and it imported the configuration from the cloud. But it's MQTT. It shouldn't do that. So never trust your IDE to import your stuff right if you're all in the same folder, I guess, is the lesson here. Really what I want to do is I want to import configuration from MQTT. So now that should be a config here, config, and I need to change this to config. All right, that's what you get for not actually trying to run your stuff before you deploy, right? We didn't test it. I'm still not going to test it. I'm just going to push this because I'm pretty confident this is going to work. Well, this is easy to check. Let's just make sure that let's make sure that this at least builds and loads, right? Node index. Config has already been declared. Oh man, we already imported it. Good thing I checked that before going through that again. And error address already in use. That's probably okay because I probably already have something running somewhere else. Okay, that's an okay error. All right, so I am going to git add, git commit to Beth Ann. To your question, are we actually doing this? Well, fix config in MQTT. Push that up, and then over here, git pull, and you'll notice that I pulled down the one change. So that's a pretty smooth process. Kind of tedious if you're doing a lot of times, but not the worst thing you could do, right? A lot easier than trying to set up everything to be able to do both, and you don't want to code directly on the server and all that kind of stuff. And so we've got that, and let's do a Docker compose up again. So it's going to go through, and it did try to start that again. So let's do a Docker PS and see if MQTT is running. Still not running. So I'm going to do a Docker compose down. And that's going to bring all these services down, and then we'll bring them back up and see if we can see what's killing that MQTT.
You not have to rebuild it?
I got to rebuild it. So it didn't actually rebuild with an up. Sometimes it'll yeah, I don't know why it didn't, but let's see if that worked. You'll notice that rebuild was really fast because all it did was change code and then do it. It didn't have to reinstall dependencies and everything inside that container. So now let's see, Docker PS. Now we should see a MQTT. There it is. So now it's running. We can also Docker logs. Let's see if that's actually running. Looks like it is. Listening. That's good. Cool. It's got some warnings there, but we don't have to worry about that. And then, all right, cool. So we're running. So we should, in theory, be able to do this, right? So fullstacksc.com port 9500, because that fullstacksc.com is just a mask over the IP address, right? We could easily put the IP address in there too. 9500 and see something. Yep, we see our node server running. And maybe we could see docs. There it is. Look at that. There's our vehicle API at fullstacksc.com port 9500. Now that's the coolest thing ever. You guys can visit that all day long if you want. Now, cool. I don't want my people to have to type in 9500 every time, right? That's not cool. That's not standard. Not to mention the fact that you don't want to do that because most IT departments close everything but 80 and 443. So even if you do that, most corporate, networks and everything are going to give you a real hard time because you'll have to ask for open ports and stuff, and then they'll breathe down your neck on why you want to do that. So usually pipe things through normal ports is kind of the lesson. Normal being 443, basically. So this is where Nginx comes in, right? And so Nginx is an archaic, legacy, exceptionally well-built, high-performance load balancer. No one else needs to ever use anything else. That's not true. For some reason, I always try to find different things to use for load balancers. And I've used so many over my 10 or 15 years of doing this. And I always come back to Nginx. And I always curse its name every time I use it, because I have to learn yet another configuration language. It's very legacy based, but it is still the best one out there. And for most things, the free open source version works. Sometimes there are some things that require the paid version, because there is a paid version. But if you want performance, you're going to want to pay for it. So anyways, Nginx, like I said, it runs probably 60 to 70 percent of the web. And where Nginx got its name, whether this is good or bad, was actually from all of the adult content on the internet, because porn makes up most of the internet. Still does. Most of the bits and bytes that go through is porn. And that's where most of the technology that we enjoy from a scale perspective was actually developed, was in the management of all of these adult content. And so Nginx really is the thing that's powered all that from the very beginning. And that's why they are the leaders, because for whatever reason, the people who are developing those websites were actually the ones using Nginx, and Nginx had to keep up with it. And so that's just where, it has truly stood the test of time, and it knows how to handle massive scale kind of loading. Video streaming, content streaming, everything goes through Nginx, and it holds it up. So that's kind of where it all kind of stems from. So let's talk about Nginx. So Nginx, we installed at the very beginning class with that apt install Nginx. And Nginx was installed in etc Nginx, and it's got some files right here. And when it installs a folder called sites enabled. There's also a sites available. It's also got modules and stuff like that. And the sites available, it's got a default folder. And in that default folder, it's got, or not a folder, it's called a default file. And if we look at that default file, it's got a server configuration. And that server configure specifically, I'll make this a little bit bigger so we can see it. You'll notice that this server configuration is listening on 80. Then you've got a server block. Kind of looks JSON-y. It's not. Definitely not. Listen on 80. It's got its own little language here. And then you got some SSL comments, but then it's serving up a web page, HTML web page. And that's what we're seeing when we visit that fullstacksc.com. We're seeing that Nginx web page on port 80, right? So prove it to you. If we go back to just fullstacksc.com, we'll see that Nginx. Welcome to Nginx. This is the line that's saying go and do that, right? And then what we can do is to just prove that more, we can edit that file. So var ww html and then index. And you'll notice it's welcome to Nginx. That line right there, let's change that to FSSE. And then reload this page. There it is. Just an HTML page. That's all it is. There's nothing, no magic there, right? All right, well, we don't want that, right? What we want to do is we want to edit this default. We want to get rid of all this stuff. So we're just going to get rid of all of this stuff. And we're going to redo it. And we're going to create what we call reverse proxies. All right, so these reverse proxies are server blocks, just like we do. And so let's work with that API. So we're going to do server, and we're going to do server name, and we're going to do api.fullstacks.com, semicolon, and then we're going to do a location block. What we're saying is at the slash, right? So fullstacks.com/, that's it. We want to handle this in a specific way, and we're going to proxy pass. The proxy pass is the directive, the Nginx directive, to reverse proxy to HTTP localhost or 127.0.0.0.1 port 9500. So what we're saying is anything that comes into api.fullstacks.com on a slash, I want you to, for anything after it, we're going to redirect to localhost 9500 because that's where our Docker container is running, right? And that's pretty much all we need. So we're going to save that. We're going to sudo service nginx restart. Seemed to work. There it is. Look at that. We just redirected slash, what do we say, docs? And there is our vehicle docs. Beautiful thing right there, right? And also, we do an API. I'll do the same thing, but it's not secure, right? Not secure at all. We'll fix that in a little bit. So our api.fullstacks.com redirected to our backend. But we need to do a few other things too, right? We need to, we're going to need to add a few additional things. We're going to need to add a, just fullstacks.com. And we're going to have to proxy pass that. We'll proxy pass that through right now. We haven't done our Netlify front end yet. We're going to need to do our, let's do WSMQTT. And where does that redirect to? Where does that proxy pass to? Anybody? 186, right?
Yeah.
But we actually have to do some little Nginx work up here. We have to call it up. We have to do an upstream because this is actually this is a socket, right? So we're going to have to do a few other things. We're going to do a server, and we're going to call that WebSocket. And then the server is a local host, and it's 1886. And then we can go back down here. We're going to proxy pass it to, getting rid of all that, we're going to proxy pass it to WebSocket, which is just the name that we upstreamed up here. We use an upstream because it's a socket, but it's not, doesn't quite work that way. We have to do an HTTP //. And there's a few other things. We have to pass some headers through, right? And those headers look like this. I'm not going to type these things out for you. I'm not going to waste the time with that. So the first one is we have a HTTP proxy version. So what we're saying is when this WebSocket thing comes through, we got to pass through those headers, those HTTP headers. And it's these. So we've got the version we got to pass through. We have to do the upgrade because that's what happens with WebSockets. It doesn't upgrade. And then we also have to do a connection upgrade. So we just got to pass those through to make sure that that's happening correctly. And then there's a few other things we got to do. We have API. We're going to need to do MQTT also. So we're going to do the same thing here. But for MQTT, it's actually the exact same thing, except it's 1885, right? And we need MQTT for the embedded domain. This has a bug in it, right? 185. All right. And I think we are good. That's pretty much all we need. All right. So let's save that, restart, make sure, we've got an error. I wonder where, this is where Nginx gets very, very frustrated. Where is our, oh, I see it, semicolon. There we go. So now it's restarted. It shouldn't have changed at all. Yep, we're good. And then MQTT, we can also pull up MQTT box. And let's see if we can connect via WebSockets to MQTT. It connects. All right. Nice. Good stuff. So, that was easy. That was almost too easy. Wow. That is impressive that I got that the first time. I'm sorry. I have to blow my own horn there because that is, I'm really surprised that that worked. All right, so we're good there. The problem is what we've got here is that this is going to do a big honkin' not secure tag up here, right? And that's not good. No one will trust you that. You know, this site is not secure, right? Well, one, that's awful because any man in the middle, you know, our bits and bytes are flowing across the internet completely in the clear text. And anyone who's in the middle of that can see anything we're sending back and forth, passwords, anything, this API doc, all that kind of stuff. Now, who cares about the API doc? But when you start typing those username and passwords in, that's not good at all. So what we need to do is we need to generate certificates, SSL certificates. Now, this used to be a very frustrating thing. It used to be very expensive, and you would get certificate authorities that you would buy these certificates from, like DigiCert, VeriSign, Symantec. You probably heard some of these companies, very large. A lot of them are now consolidating because there are now free options out there that are just as secure. But a few years ago, probably 2 or 3 years ago, a company, an organization, not really a company, nonprofit called Let's Encrypt came around. And Let's Encrypt believes in a free and open internet. And they said, we're going to give out free SSL and TLS certificates. And we are going to try to get our root certificate into all browsers. And they did. They successfully did. And so now all of our browsers, Google Chrome, Firefox, whoever, Safari, they all have the Let's Encrypt certificate authority, root certificate in it, which allows us to generate certificates and SSL certificates, verify them with Let's Encrypt, and be able to encrypt our connection back and forth between our client as well as our server. But we need to install those certificates. And that in and of itself is not a particularly as straightforward process. There are certain load balancers that will do it for you, like Caddy kind of specializes in that. Automatically create everything SSL and TLS. We're going to do it somewhat manually. Number one, because it's good to teach it. Kind of gets you to see, but it's not as much magic, right? that's happening here. A lot of sometimes they'll just there's these load balancers or proxies will just generate them for you, these certs for you, and you never know it happened. But it's good that we go through this. So Nginx isn't quite as slick as that. You have to do some hand tinkering to get this to work. But the big thing here is in order to install these, we need to install a utility called certbot. And just like we installed Nginx, just like we installed Docker, certbot is released by Let's Encrypt as a utility to generate certificates. And so I'm going to do this, and let's see here. Let me update. I just did this. Literally today. What is going on? Well, apparently something broke. Between today and, well, tonight.
It'll probably run off of Debian, which is just apt-get install certbot.
Now you gotta add their repository.
I think it's in Debian already.
We'll see. This usually doesn't work. Nope. All right. Well, we'll see if this works. So I'm going to say sudo certbot. I want to install the certificates on Nginx, and I want to do them for domain api.fullstackse.com. That's the first domain I want to create a certificate for. Does not appear to be installed. That's what I was afraid of.
I think, isn't it it's the plugin for Nginx, right?
Yeah. Yeah, but it's not installing it for whatever reason tonight. Oh, all right, that worked. So let's see. All right. All right, I'm gonna enter my email. I'm going to agree to the terms of service. I don't need to share my information. And what it's doing is it's actually setting up a little server. This little thing is setting up a little server, and then it's going out to Let's Encrypt and saying, hey, certify that I own this server. And it's running a little port 80 server, so you have to have port 80 open, which we do. And it's now verifying that when we're generating the certificate that we own this server. So only we can generate this certificate for this domain. And oh, guess what? You also have to have your domain set up so that it will go through the DNS. If you noticed, we asked it to generate it for api.fullstacksc.com. If we tried to do it and we didn't have the domain set up, the DNS set up in Cloudflare, it wouldn't work because it couldn't verify that you had intentionally set up your DNS in order to do that. So that's how that works. It's now asking, do we want to redirect or no redirect? And all that simply is saying, do you want me to set it up so that we always automatically redirect HTTPS? So if someone intentionally types HTTP and go, it will automatically redirect them to HTTPS. That's a good thing. So we're going to say to yes. So it's redirecting it all, and we're good. Done. Now, what did that actually do? Well, as it turns out, we can look at our Nginx config again. And if we look at api.fullstack.sc server block, it actually put code in there for us. It put a configuration in there for us. And it configured our block, our Nginx block, our server block for api.fullstacksc.com to include the certificates. And where did it install the certificates? It installed them in this folder. ECT on this machine, on this this root machine. Let's encrypt live API full stack full chain.pem. That's a cryptographic signature. Same thing here, SSL key, and it includes the configuration. It's got some parameters in there, and we're good to go. Here's the other thing down here. It added a server block, another server block to our configuration. Why did it do that? Well, we wanted it to redirect. So it configured Nginx to automatically redirect from port 80. So if you're just looking at API, redirect to make sure that you also listen on 80, but then redirect to 443. So it's going to do a permanent redirect 301 to HTTPS. This one right here to the host request URI. So we're just automatically just redirecting. You can do some really crazy stuff in Nginx. You just got to learn their little scripting language. All right, I know enough to be dangerous. In fact, I know enough to be stupid with it. I do not know Nginx configuration. I've just over years have just beat my head against the wall enough to get something that works, and this is what you're seeing. I'm sure there's a billion different ways to do this, and there's probably a better way to do it, but it works for me, so that's what I'm teaching you. All right, so we got that. We have to do a few others. We got to do WS, MQTT. And then we also have to do MQTT, and we have to do fullstacksc.com, all of which are pointed through our domain. And 2 redirects. And then we'll do this, MQTT. And then I know that certbot also allows me to do this, MQTT, and then just fullstacksc.com. Now, you probably may have heard of things called wildcard certificates. So that's star dot your domain. You can also do that, but it requires an additional setup. additional plugin, an additional step, because wildcard certificates are relatively dangerous. Because if anyone gets access to the PEM files that I showed you in there, that's not good, because then they can install them on any server that they want, and they can, even worse, break your encryption because they have your SSL certificate. They have the private key for your server, so they can sit in the middle of anything that you're encrypted and just decrypt it. So defeats the purpose of encrypting it, right? Because they got the key. So that's why you kind of want to make sure that that you're doing things, you protect those things pretty tightly. And that wildcard, you got to be pretty careful with it, because that's they can basically do anything with that on your domain. All right, so we got MQTT secured, and we also have that. We now should be able to go back. That automatically restarted Nginx for us. We should be able to go back, press enter, and it should have automatically redirected. I have JavaScript. Should have automatically redirected, and now the connection is secure. Google's happy with us. The world is all better, right? And now we have a very nice, elegant URL. api.fullstackse.com/docs. That is a beautiful URL right there, right? That's pretty cool. Pretty cool. All right, so we have pretty much everything configured. Let's see if this worked out. Let's do WSS. CA signed, save, connected. So we also are able to connect securely to MQTT. This is not something that everyone does. Not very many IoT people out there are actually securing their MQTTs stuff. So one of the things that I'm really on a mission to fix. We need to install those certificates. All right, so we've got all that, so that's good. What's next? Well, we basically need to do a few things. First of all, we don't have our data model loaded up, right? Because we installed a new MySQL, so we got to do that. And then we have to install CI/CD. So we got to make this thing all work together. So when we push a code change, it just works, right? We also have to do our front end. We haven't done our front end yet. So let's do our front end first before we do the other stuff. All right, you might ask, why are we doing the front end separately? Why can't we just run it from a server? You can run it from the server. In fact, if you're going through this trouble, you might as well. The reason I'm doing it here is because, one, we use Netlify almost exclusively for our front ends, because it's a relatively nice service. And the other thing is it shows you serverless. Now you might have heard this buzzword, serverless computing. Anyone heard this buzzword? Serverless computing? All right, well, it's a buzzword in the technology sector, and particularly in DevOps. And it's kind of a weird thing if you think about it, serverless, right? Let's go serverless. Well, there's no magic to it. Serverless still has a bunch of servers. It just means that someone else manages the servers. You just don't manage it, right? And you deploy your apps. And so when you hear things about serverless, it's like, hey, I got my code in my little bundle, and then I specify a Docker container on it, and then you manage it. Like and you deploy it, right? But I manage the code, and it's all pretty standard, right? I mean, we saw how streamlined Docker is. You can do that now. And so it's Docker that actually enables this serverless stuff. Well, Netlify doesn't do any back-end stuff. They don't manage any back-end or databases or anything. They just do static sites. They just do static front-end sites. It's not totally true. They've, as of today, actually released an announcement that they do have functions. So serverless functions that you can deploy things. That's kind of cool, and we're going to check those out. And then they also have a few other things. Netlify is just a really nice service, and a lot of people use them. There's a number of different services like Netlify, though. They're not unique. There's Surge. There's like AWS has their serverless Beanstalk and Compute, ECS. GCP has their app stuff, and then Azure has their functions. So you can do all these, the same stuff. But I'm going to log in here and log out because I need to log out. Got too many accounts here. So basically what we got is I created one here for us, I think, so you don't see all of my deployment. Yep. All right. So I already have one deployed here. This was my my solution. So we're gonna do a new one here from our repository. So I'm gonna do a new site. Let me think. All right, we're gonna new site. You see so far it's real easy. I just logged in, and the registration is just as easy. So you log in, and I say, all right, what do I need here? Well, I can deploy directly from one of these services. Well, we use GitLab, and I'm going to authorize for GitLab, so it use single sign-on. So I was already signed into GitLab with this browser, so it knew my token because I was literally signed in here on this tab. Used server-side cookies, right? When we talked about J2T tokens and everything, that's how that worked, kind of. And it lists all of my stuff here. I'm going to search repos. I'm going to go bootcamp, full stack bootcamp, and let's see if I can find bootcamp content. There's our week 9. That's the repo we just created, right? And here's the cool thing. It says, all right, branch to deploy. This is my team name. Yep. And I can do a build command. And that's I'm going to just do yarn build. If we go to the code here and go to our front end, and something we haven't been doing yet is building. We've only been using the development server. What building does is it takes all of our code and compiles it into, or transpiles it into a single JavaScript file and bundles it. It creates a bundle that basically rips out all the warnings and all that kind of stuff, all the dev tools. You know how you can hot reload and there's all that magic that happens that, every time you make a change to the front end, it auto reloads and everything for it. Well, you don't want that in production because it just slows stuff down. So it just rips all of that stuff out when you do a yarn build, and it just creates a nice little package in the build folder. So that's what we want to do. So we're going to do a yarn build, but first we actually want to make sure that we're actually publishing in a published directory. And what we need to do is, if we look at our directory here, we actually need to publish in front-end React. And we need to publish in front-end React, front-end React/build. And the reason is because if we look at our package.json, when we say yarn run build, it's actually running, when we say yarn run build in these scripts, it's actually running this React scripted build, which is creating, by convention, if you read the documentation, it's going to create a folder called build. It's going to bundle all its stuff, and it's just an index.html with a JavaScript file with all the assets like pictures and stuff that you want. So we need to do that, and then the build command is yarn run build. And I think that there's a few other things we need to do. We also need to add a new variable. Now there's environment variables here too. Specifically, we need to point the front end towards our back end. Because if you think about it, what we've been doing so far is we've just been pointing our front end to localhost 9500, right? Well, now that's different now, right? Now we need to deploy it to fullstack.se, api.fullstackse.com, right? So we can go in our thing here. We need to go to lib. And where does that happen? Well, that happens, I think, in API.js. It happens right here. We've got a couple of things here, right? That's cool. So we're going to do process.env.react app. And I'll just do API base URL or this. Pretty straightforward. And we also need to do the same thing for MQTT. And I'll just do WS or MQTT. There we go. So we got that. That'll work. Now, why did I append React app? This is actually critical. As part of the create React app, which we used to set up all this scaffolding for us. Remember, we just used create React app and did all this magic for us, set us all this up for us. In order for it to take environment variables during its build cycle, you need to prefix all of your environment variables with React app. So that's why that's critical. So you can't just, like our backend, just pick whatever name you want. You need to prefix it with this React app. So we got to do this one. We have to do this one. All right, what goes in there? I'm tired of talking. What goes in there? Anybody?
API dot
Close.
full stack.
Close. What else?
WS and QTT.
This down here is WSS, right? .ws dash mqtt dot fullstack.se.com. And what's that?
HTTP, right?
There we go. HTTP. You sure?
S.
Yes. There you go. API dot fullstack.se.com. All right. So hopefully this will work. I don't know. We'll check this out. I don't quite remember how this worked. This is not gonna actually work because I didn't push this yet, but that's okay. Let's see how this works. So what I did, this is so cool. What I did was I said deploy site. So what it did was it went out, grabbed the code, wrapped itself into its own little Docker container, gave us these logs, and you can see all the stuff that it's doing. It's pulling, nope, can't find it. Command yarn run build right here, can't find all that kind of stuff. So that's pretty cool. Well, it's cool that it's trying. It didn't actually work. So let's go back to our deploy settings. And let's see here. Got our environment variables. Let's edit these settings. Publish direct, base directory. Front end React. I think that's the problem. Let's do build. And we will let it decide yarn run build. That's all right, we'll do that. Let's save that. And here's, let's do this. So we can either trigger deploy from this, so we can just automatically let it do the work, or what we can do over here, update front end environment variables. So we're pushing that, and you'll notice that once it gets pushed, it will build. So that's CI/CD right there. Only for our front end right now. But that's pretty cool. And we changed the build directory to that front end React, right? So now Netlify knows to look into our repo among all these folders and go to front end React and build from here. Look for that package.json. Let's see if it's doing it. Looks like it. It found it. Look at that. So it's actually, it's took like an Ubuntu base image probably that's special built for this. It's installed a few tools, installed yarn. There it is, right? Verifying the run directory, building. It's creating an optimized production build, running that yarn run build, and it will deploy. How cool is that? Isn't that sweet? So you can just make a change in your code, push it. It'll be live in a matter of minutes or seconds, actually, in some cases. So, oh, failed to compile. Darn it! Spoke too soon. Let's see here. Oh, I know why. So there's this. Netlify's been doing a lot of updates. I think they became a little big and had some stuff. So the issue is, we have some warnings in here. I of course would never create those warnings. I'm sure that's all JC. But the problem is Netlify CI/CD is failing because of those warnings. So it's being really strict. It's saying if you have any warnings or anything as part of it, it's going to kick out. It's going to say I'm not going to deploy. So, but it does give you a nice little hint that says, hey, if you don't want that, if you're okay with warnings, just set this environment variable CI equal to true, and we'll skip them. So we're going to do that. Let's go back to our deploy settings, go down to our environment variables, edit variables, add a new one, and we'll just set CI empty, which is what it actually said to do. And then we will go back to deploys, and I don't have anything to push, so I'm just going to clear the cache and deploy the site again. So it'll do that. Now you might ask, this is completely free. Well, it's not actually completely free. It's free for a certain amount of build minutes. And so I don't know what I think it's like 700 build minutes a month or something. And so it's actually to your benefit if you want to stay under that. We deploy a lot, so we usually pay, like Technics of Odessa, we're always paying for additional build minutes. It's like $7 a month for an additional like 400 build minutes or something. But you can imagine, like, we just sat here for a few minutes, and that's eating our build minutes, our free build minutes for this account. So it's not free. But if you're doing like simple stuff, or you're smart about the build sizes, or try to optimize the time that it takes to build your sites and everything, that you can save money that way. So there's a whole, that's part of DevOps, is optimizing those run times and build times and everything. And that's why you start to hear about languages. I think I mentioned Scala or something on Tuesday recently. People got away from using Scala as a language because the compile time was just so freaking long. And so when you wanted to deploy something, unless you were running your own infrastructure, you just couldn't deploy it because you were burning up all your build minutes all the time. For anything, for doing any kind of CI/CD or any of that kind of stuff. So there it is. That's what I wanted to see. Site is live. So let's go and check that out. Let's click this preview deploy. I need to enable JavaScript. I'll enable JavaScript. There it is. Look at that. It is live. Now, what the hell is this thing? Where did that come from? Well, that actually came from Netlify. Netlify uses its own domain, netlify.app, and assigns you a random subdomain, and it generates its own cert automatically, just like we did. It just automated that with a simple script. And then you can also, if you want, let's just do this. Let's go to overview, and we can go site settings. We can change the site name. And we can change the site name to FSSE 2020-1. And so now the site is FSSE-20-1.netlify.app. So we don't quite get our brand, but we can at least get a little bit of a cleaner, that's okay, right? This still isn't good. I want that fullstackse.com, right? I mean, this is the entry point into my site. I don't want people to be going to netlify.com. There are a few things you can do. Netlify is really nice in that it's free. If you decide to do your own, just like we use Cloudflare to manage everything, they also provide a DNS. management, so you can actually do your zone records and stuff through Netlify, and then you can manage everything, including pointing it to your backends if you want. You can do that. Or in our case, let's use Nginx and proxy to this URL. Now you might say, performance on that? Yeah, there is a performance hit because you're not sharing infrastructure. Like Netlify is not on DigitalOcean, so your users, in order to get to your site, are going to Nginx first, which is on a DigitalOcean server in New York region, to wherever Netlify's build and serving is. Probably, if I had to guess, on AWS, probably somewhere in the East region. So it's not that far, but it still is. It's probably somewhere in Virginia, if I had to guess. So, I mean, it's you know, there are, you have to think about these things. If you're like a really trying to get an amazing sort of performance, these are things you think about. It doesn't really matter until you get to like massive scale, or you're really tuning really tight. So let's now do the proxy pass. We actually already set that up and generated the cert. It's right here, right? So what we want to do here is we just want to paste that thing in. So anytime you hit fullstackse.com, we're going to go to fsnetlify.app. Really easy. So proxy pass, not just locally, but now we can proxy pass back through to another server. And sudo service nginx restart. So we restart that. Come on. And now there it is. Right there, fullstackse.com with our login and everything, fully deployed. How cool is that? Now, there's one additional thing we've done. It's not that great. Well, we haven't quite done our full CI/CD yet for our back end, right? We haven't done on the front end. So every time we deploy the front end, it'll do that. But here's the thing. We're deploying, if we look at our settings here, if we go to our deploy settings, we're deploying from a master branch. Anyone see a problem with that?
Oh, is from the root, from the server, Ubuntu server? That's what the master branch is all about?
Yeah, well, the master branch is basically for everything, right? If we look at our project, it's got all of our folders in it.
Okay.
So if we make a change, right, to our back end, that's going to redeploy our front end too and eat up build minutes unnecessarily. We don't need to redeploy the front end, right? So how do we fix that? Any ideas?
So
Partition out separate branches?
Separate branches, yeah. That's right. Who else was going to say that?
DeepMind.
Good. I'm glad. No, that's good. That's good. So it's separate branches. So here, let's create an additional branch. Let's do git checkout -b front end master. Switch to new branch, front end master. Nice. So we just pushed up a new branch. Very simply, no changes to code, new branch. We'll go here, and you'll notice there is now a front end master branch. And every time that you make a change to the front end, we're now diverging, right? So you're as long as you stay on front end master to make your changes to your front end, and you know that that is your branch, this is convention, you just agree as a team or whatever that that's what you're going to do. Doesn't matter if the other stuff's out of sync, you can still keep one repo. But as long as you're always deploying a front end master, then you're going to be good. And the only thing we have to change is we need to go here, we need to edit these settings and just do front end master. We can set some other things like merge request, like only do it on merge requests, things like that after they've been approved, so you can have some governance around that. And so now, I don't think it picked up the change yet because I just did that. I don't know why it's not picking that up. There it is. All right. So so there you go. Production branch is front end master, and it just needed to communicate back with GitLab to the API to make sure that it did that. And so now, anytime we make a change, then it will automatically deploy. So let's just prove that. Let's go to our screens, login. Let's add a thing down here. We'll just came from viewer to app, right? So we're pushing that. Let's go to our deploys here. There it is, automatically. It's already building because we pushed it. We can watch it build. Once it builds, we should be able to go check it, and we should be able to see on that login page that the optimized build was working. All right, cool. So we'll check that once that's done. Site is live, already done. Ooh, what happened there? As it turns out, you're gonna have to add something to our front end.
Yeah, if you so if you remove that login page, then it'll be fine.
Right. Exactly. It'll be fine. Now we got our app, so it redeployed. But here's the thing: if we try to log in and go to another page, it's not going to work, right? Well, that's because how Netlify manages its redirection and everything. And so Netlify provides, you can go and search around for this and everything. Netlify provides some documentation on that. But what it comes down to, really simply, is you need to create a new file called redirects in your public folder. And Netlify is going to look for that. And it's going to say any redirect, so anything after the slash, always redirect to index.html and give me a 200. Why do we do that? Because we're a single page app, right? Netlify also supports static sites that are actually served as file systems with different pages. But since we only ever serve one HTML page because we're letting JavaScript manage everything, we need to tell it, well, we're still using the URL, so it may look like it, but we really just want every single URL to redirect to my index.html page, so I let my JavaScript handle it. So there we go. We got to git commit the redirects. Make sure we push to our deployment branch. And go back up to our logs here. Oops. We're already building again. Oh, yeah. Oh, I clicked on the commit. So it took me to the commit to see the code. And it's building, and that will fix it. So there's a little Netlify trick. You'll notice that there's all these little things you gotta, and every single service is different. Every single one of them is different. So there's all these little things you just gotta, that's what makes deployment so frustrating, and why when you learn a tool, you stick with it. Because when you go to a new one, it's got its own little quirks, like that little redirect. It's not that that's a quirk, it's more of how Netlify handles it is a bit of a quirk, right? It's just how they chose architecturally to do that. So, so here, should be able to do the redirect now. Yep, we got our app. So now we got the /login. That's fine. Everything's good. We should be good to go. Can't log in yet though, because we got nothing in our database. So we need to do an initial deploy here of our database. And so Docker PS, we've got our MySQL running. All right, so we've got Docker PS. So what we have to do is we need to do that initial data load, right? So the only way we can do that is, one, we can install a MySQL client on this machine and then log into the MySQL container, right? Through the 3310, the port 3310 that we exposed. Or what we can do is we can log in directly to the MySQL container and then run our data model script, or basically our data model.sql, right? So let's do that. So we're going to say docker exec. So we're going to we're going to execute right into it, -it, and I need the MySQL container, and I want to run bash, because I want bash. So now I am in the MySQL container, and I'm going to do MySQL u root -p root, and what is my host? Localhost, because I am inside of the MySQL container, right? And so now I am in MySQL. So I can show databases. Nothing in there, right? So I need to load up my my thing here, my data model, which is in data model. So I can do this, kind of copy it and just run it. There we go. Now my data model is loaded up. I can do show databases. There's my FSSE vehicle in there now. So now my production deployed MySQL container has that in there. I can use FSSE vehicle. And I can do select star from user. And it's got lorem ipsum in there. Nice. So you can try logging in. I'm a little bit nervous to do that. I don't know if it'll work, but hopefully it will. Let's set up, before we go crazy like that, let's set up CI/CD. Don't want to spend a bunch of time on that. We'll do that if we can. All right, so that's the last thing we got to do tonight. It's actually gone better than I expected. Usually these deployment things end in kicking and screaming and throwing your computer across the room. At least that's my case. So what we need is we need to basically emulate what Netlify does for us, but on our back end and our Docker, which is a much more complicated process, right? I mean, with Netlify, all they're doing is just taking one little web app and putting it up, right? We have to do all this kind of stuff with Docker. It turns out it's really not that much more complicated, but we got a little bit more choreography we got to do. All right, so got to get out of my SQL container here. I'm good to go from here. So there's a number of different things we could do with CI/CD. Number of different services we can use. There's Circle CI. There's GitHub has something. GitLab has something. That's what we're going to use. So GitLab has what they call GitLab runners. And they actually have a whole thing. So here's our repo, right? They have a whole thing called CI/CD. And you can build CI/CD pipelines in GitLab. So every time you push to like the master branch or something of your repo, it will run CI/CD pipelines for you. And what that means is it will follow a script that you write, and it will deploy all of your stuff. Now, that's really esoteric, right? I mean, it's like, how does it know all that stuff? There's got to be some magic in there. And yeah, there's some, but they have these, this is a really cool model. I really like this model. They have these things called GitLab runners. And GitLab runners are little things, little appliances, little Docker containers that you run on your server, on your deployment server or your build server. And what they do is they communicate with GitLab in a secure fashion using certificates, and they just listen. And so GitLab triggers with a webhook these GitLab runners that are sitting on your build server to then run your scripts on your build server and then deploy all your code. So as it turns out, none of your stuff actually runs on GitLab at any point, other than when you other when you push your code up, it'll do a redirect. But it's basically just hitting your server. It's just doing all of the work for you, of hitting your server and choreographing that, and it's running everything on your server in order to do that build process. Now this will get a little bit more clear as we go here, but so basically what we've got is we have to install the GitLab runner first. That's the big thing that we have to do. And so to install a GitLab runner, we can go and search for it, but we can say install GitLab runner on Linux. We've got all this kind of stuff, and it's like a curl thing, and so I'm just gonna pull it down, copy and paste it. This is just a GitLab runner for an AMD 64, and I'm just gonna follow these directions. So I've got to install the dev package that was the RPM package or dev package that was done it, and then what I need to do is I need to register the GitLab runner. But what am I doing here? What I'm doing is I'm actually registering this runner, which was just installed. It's a piece of software. It's almost kind of like an IoT thing. I think of it almost as an IoT thing, because it's a thing that's running on your server that's listening to GitLab, and then doing something that you're commanding it to do. And so you have to register this runner that we just installed, this piece of software, with GitLab in order to make sure that, one, it's secure, but two, it knows what it should be listening for. And so what I'm going to do here is I'm going to go back to our repository here, and I'm going to go to Settings and CI/CD, and you'll notice that there's a whole runners section here. And we've got, we can install everything. We can also use the GitLab shared runners. They actually have their own little servers that run, and they'll scale and everything. And so you can pick one of these. I don't like doing that because, one, I don't control those at all. I don't know who else is running on those. And then two, you only get a certain number of minutes, and it's pretty limited. Plus you have to wait for others. So you get queued up, you get what you pay for, right? You aren't paying for it, so you're going to get queued up. You could wait a long time for a build, and so we'll do this. So basically, it's saying we're installing our runner manually on our infrastructure, so we control that entire pipeline and all that kind of stuff. So we're going to put our runner setup here. So I'm going to GitLab runner register, and I've got to put this thing in here. All right, GitLab.com, and I've got to, this is the registration token that's specific to my project. So this is generated for each repo. In this case, is our week 9 repo. Hopefully, yeah. And so we've got to do that. And I've got FSSE deploy, that's just a description. And I don't need any tags, and it's succeeded. And then I'm going to use Docker for my runner, and the default Docker image is going to be Ubuntu Bionic. Don't remember actually. You remember, JC? I don't want to screw this up because this could end poorly for everybody. Yeah, I'm going to do Ubuntu Bionic. So it says that it was successfully registered. It's already started. And so we can go here and refresh the page. and settings CI/CD. Go to the runners again, and you'll notice that here is our FSSE deploy. So our runner registered itself, running on our backend, registered itself with GitLab. Okay. Now you might say, all right, okay, so what do we do with this now? Well, with this, now we can start to write configuration scripts to actually put together a little runtime, a little script that's going to tell our backend what to do to redeploy. Now, if you think about it, it's like, geez, how do you do that? Well, we just did it, right? We just set up our whole backend, and it's actually very simple. It's like 3 lines to start and stop this stuff. And in fact, we can go through it real quick. So basically what we want to do is inside of this week 9, what we do is we do a git pull, right? We do a Docker compose build, right? And then we do a Docker compose down and a Docker compose up. And that's going to refresh our entire backend, right? So that's a pretty simple process, and those are all just command lines, commands, right? So that means we can script it, and that's what we're going to do now. GitLab with runners gives us a specific direction here when you install a GitLab runner, and you have to read the documentation. But in the documentation, it tells you if you include a file in your repository. So in the main, in your main repo here, if you install a file called .gitlab-ci.yaml, a YAML file, it will automatically use that, and that is where you can script all of your different build steps. All right, so the other thing is, if you remember this YAML file, or if you remember what I did when I created that runner, I said I wanted to use Docker. So what's actually going to happen is this GitLab runner is going to boot up a Docker container. This Docker thing keeps coming up over and over and over, doesn't it? It's going to boot up a Docker container, Ubuntu Docker container, and then it's going to run a little thing inside of it, and that little Docker container is going to create a little SSH client, and it's going to SSH into our server. And what it's going to do is, once it SSHs into the server, it's going to go to our week 9 folder, and it's going to run those commands we just talked about, that git pull, Docker push, or Docker compose build up, and then that's going to do our CI/CD. So we're actually using the Docker container SSH into its host to then run those commands. Now there's a few things we have to do first, and that is we have to make this YAML file. And so to save some time here, I'm going to say Ubuntu Bionic. There's also this YAML file is defined by GitLab, so you can look at the documentation, but they have stages. So these are deployment stages. Part of CI/CD is also running through a test. So remember all those Mocha tests that we wrote a while back? I'm not going to do it here, but a stage could be a test stage. And so if all your tests pass, you can run your tests, set up your entire infrastructure, run your tests. If they all pass, then you can move to the next stage. If it fails, then it won't deploy. So that's another check to make sure that, on that very last phase, that you're still passing all your tests so that you can be safe in your production. That's part of the CI/CD. We're skipping over that part right now, but that is part of a true CI/CD pipeline. I would probably guess that 90% of all CI/CD pipelines out there do not actually run the tests. I think because it's hard, people, setting that up is frustrating. It's one of those things that we as development people or deployment people like to say, yeah, we do tests on our CI/CD. It's full CI/CD. It's not, because we get lazy. and all that kind of stuff. But if you actually have your tests running, that's a really good thing. That's you've basically you've arrived kind of thing in CI/CD. So I'm going to name this stage deploy master, and then I've got a before script that I'm going to run. And JC wrote this probably last year or something. And what this does, it does a lot of stuff, but it really all is simply it's the basic thing here is that it's running this script inside this Docker container to set up the SSH agent. You'll notice a lot of these commands we actually did today already, like SSH agent, install OpenSSH client, evals the SSH agent, and then what it does is it will put the private key that we provide, the private key to the server, to the host, which we have GitLab, right? Remember we generated that key, GitLab key. So we're going to put that in as the private key, and what we're going to do is we're going to make the directory, and we're going to put our production server IP. So this is general. We can inject environment variables into this through the Docker build. And then we're going to key scan this and then change the permissions on it because you have to, and then set it up so that then what we can do is we can run the build script called the build stage called deploy master, which we've defined up here. And this deploy master is stage deploy master. The script is just an SSH into our host container using the appropriate keys, and only do it for master branch. So a lot of this is boilerplate, and you'll notice I just copy and pasted it in because that's what we do now. You do it once and you just kind of use it, boilerplate. All right, so what do we have to do? Well, we have to configure some stuff in GitLab here in our repo first, and we have to set up CI/CD settings, and we have to set up some variables. All right, so we have to add some variables here. So the first one we have to add is we have to add a production server IP, because that's where you have to SSH into, right? And so this production server IP is we can get that from our DNS. That's this, right? That's our production server IP. We need to remote into that in order to, we need to SSH into that in order to kick this off. So we need to add a variable. The value is that, and it's called production server IP. It's a variable, and we're gonna protect it. All right, so we got that. We also have a server user that's going to be root in our case, so we're going to add another variable. We're going to add that. Then we have to add one more, and that is this private key. And this private key needs to be injected so that into this specific container. And so if we do that, we need to get this private key. Grab that, paste that private key in there. This always makes me a little nervous because what we're saying, we're giving GitLab access to our server here, right? But you know, you gotta put some trust into something, so this is where we're doing it. There are other strategies for protecting this. When this is one of the reasons why you go to larger infrastructures like AWS or GCP and use their own CI/CD because it's all combined. They have key store strategies. You use very specific things, and it's government grade kind of stuff. So this is, you know, this is good enough for now. But yeah, if you want to go really serious production, you're gonna go to the big clouds and use their own CI/CD pipelines, which all operate like this, just in different configuration ways. All right, so you got that SSH private key. And let me see. I think we are good at this point. So let's try it. So we don't have anything here, but git checkout master, and we're gonna git add, git commit, update CI, and we're pushing that GitLab CI file that we added. And let's see if it kicks it off here. It did. Look at that. So it kicked off, that runner kicked off a build, and it's running. And deploy master. So it's running this. So just like in Netlify, we can see the logs here. And it failed. Permission denied, public key. So something up with the SSH key. Let me think. So what do you think, JC?
I would actually log them inside of the before script just to make sure that the environment variables are coming through, because sometimes during copy paste, I don't know what goes on with their interface, but it doesn't accept it. So just for good measure, I would take every single one of the environment variables and do an echo.
Did you put the private key in there?
Let's see if this echoes it here. So there's the private key, Clayton.
Wouldn't you be using the public key though to sign in?
And
Oh, you need to add the public key to the authorized keys list on the server. That authorizes itself.
Yeah. Good call. All right, so we are in this SSH folder. We're using this GitLab, right? Because we use this GitLab private key here. And so we need to authorize this public key to be accepted, but we haven't done that yet. And so we need to gitlab.public. We got to get that. And then we need to edit this authorized key list, which has my key, and I added JC's key over the break. So I'm going to add this here so that this can be logged in via public key, right? So I could have also created a new key if I wanted to, and use that there. I just used both keys. It didn't. I already had it created, so I might as well have just used it, right? So, and GitLab knows about both, so whatever. All right, so if that's the case, I can kick this off again, retry, because none of my code changed. So I'm gonna kick it off again and go to jobs, and let's see if that worked. This is actually still gonna fail because we haven't actually yet put in any, we haven't told the runner what to actually do with anything. We just got it to kick off and start running, right? So we haven't told it to do that Docker stuff and reload and all that kind of stuff. So, no, we're still running into weird issues here. No such file or directory. Well, yeah.
What's in deploy prod? And that deploy dash prod.
That's probably what it is here.
Oh, there we go. Yeah, it's that SSH right there.
think that this is what I have to do, right?
Yeah, we have to add the SSH identity for GitLab right before going in. That way it can manipulate the repos.
All right, cool. Now, I'll just do this here. So this is going to work, and then you'll notice that this is just really one long command, right? That we're running. This is what does all the magic of doing our deployment. Well, the magic is actually, so this is just a bunch of stuff here. This is like SSH agent. We're adding the GitLab key that JC just mentioned. We're seeding into week 9, right? We're going to CD into week 9 here. And then we're going to check out master, right? And then we're going to pull the origin master. And then we're going to run some magic script called deploy prod sh. Now we haven't defined that yet, but that's where the cool stuff starts to happen. So this deploy prod sh, we're going to have to add this here. So let's add another file here. What deploy prod .sh. So this is a bash file, and a bash file is just command lines. Commands on the command line. So we got bin /bash, and first of all, we're going to do a git checkout master just for good measure, and we're going to git pull origin master again, and then we need to what we'll do is we will do a Docker compose build first. So we're going to rebuild all the containers because we now have the new code, right? So we've got to do a rebuild. Then we're going to do a Docker compose down, and then a Docker compose up -d. Pretty simple, right? Those were all the commands that we just did to set up our server. So we should just be able to automate that, right? So we've got that. And then why did I build first and then bring it down? Well, because building can take time. So why bring it down, build, and then bring it back up when to get maximum uptime? I might as well build first because that's not going to affect what's running in memory. Then take it down quickly and then up. So we're going to try to minimize any downtime. There is a thing that we use most of the time. We do this for like our whatever regular systems, development systems, but we use something called Kubernetes. Which is a whole orchestration layer for Docker and Compose and all this kind of stuff. It's really incredible, and it basically does auto rolling updates so that you never have any downtime. Period. So that's one of the features of Kubernetes, one of the many. That's also a very frustrating tool, very very complex to manage, which is why we don't typically do that. We'll talk about that next week. All right, so we've got that, and then this. Fix deploy push. Let's see. Oops. Let's do the jobs here. Let's look at the running job here. All right. Got a bunch of emails piling up of failed pipelines because GitLab will automatically email you. It says your pipeline failed. There it is. Look at that. It did the build. It's stopping all of them. So now that's the Docker down, Docker Compose down. Removing, and then Docker Compose up. Created all of them. If we go back here, do Docker PS, and they're all running. Look at that. So, talk about systems working together, right? This is real systems engineering, guys. I mean, this is everything coming together and working. So full stack SC docs. Looks like it works. That's good. Let's make a change here in our code. So let's change this description in our documentation. That's the quickest, painless, easiest thing to do real quick. So let's go find that. That's in cloud, I think, and in index, and it's in our Open API spec. So let's just do a vehicle API for full stack system engineering, FSSE, an API for AV with some more description. Git add, git commit, update doc, git push origin master. And let's check that out. You might also ask, wait, is GitLab free? Well, it is right now. You also get limited build minutes, and as of today, they also are limiting build minutes to 400 minutes a month. Just got an email about that today. I was like, darn, I was loving my like unlimited build minutes on my free account. All right, so it's initialized that, and you'll notice it keeps track of the amount of time that you're running and all this kind of stuff. Stopping it and then bringing it down. There's also a Docker Compose reload that you can sometimes use that will do it with no downtime at all. It doesn't always pick up the build though, which I've noticed, so I have to investigate that more. So let's check that out. We expect some changes here, right? Nice, there it is. Auto deployment. So all we had to do was change our code, git push, and it now appeared for everyone. That to me is like the coolest thing. I mean, we have now in 9 weeks, we have gone full circle from scratch, from nothing to deploying on the World Wide Web in a CI/CD fully automated fashion. Now that's systems engineering right there, if I say so myself. So that's basically what I wanted to do today. So hey, we even did it with time to spare. Imagine that. I was like, we're never going to get all this stuff done. At least what I wanted. I know JC wanted to do something. I don't know. I'm a little bit nervous to try to log in because it may not actually work. I'll let you guys try to log in. That's homework. Fix anything that I messed up. I'm going to leave this up. And if you guys give me your public keys, I'll add them to that server. I'll leave that server running for a bit. You guys can mess around with it if you want. You guys have access to that week 9, so you can look at it. Keep in mind, you're all looking at it. You're all changing stuff, so it is one repo. You're a cohort team, so maybe Tuesday, ask us questions or whatever about it. Maybe we can go through it. If you mess something up, we can go fix it. That kind of thing. So play with it a little bit. And then Thursday, what we're going to do for next week is I'm going to give you kind of more of a lecture style on advanced deployment. So we're going to talk about AWS, GCP. We're going to step through those consoles and stuff, and Azure, as well as Kubernetes. We'll talk about that and other CI/CD types of tools that you'll see. And then we'll also go over native app development. So that's Android, iOS development. We'll take our FSSE app and we'll put it on the phone, on your smartphone, and that'll take us to week 10. And 11 is going to be optimization. So we're going to do microservices, and then the last week, of course, is wrap up. So pick up anything we didn't cover and all that kind of stuff. So anyways, that's we're nearing the end here. I know that was a ton of information, a lot of new stuff. But was it really? If you think about it, yeah, a few new words like netlify, you hadn't seen that before. But if you think about it, we used Docker and Docker Compose all the way through. We used GitLab. I mean, that's where you go and see all your stuff. Now, whether or not you've been using GitLab religiously, which you should have been, but it maybe not, but you see why it's important now, really important. GitHub has the same thing. Yeah, GitHub, it's called GitHub Actions, the CI/CD thing. So GitHub does kind of the same thing in a slightly different language and flavor, but same kind of CI/CD thing. And what else did we do? I mean, we used Docker, right? Been using Docker.
Cloudflare, or
Cloudflare and the DNS stuff, yeah. That is true, but that's DNS stuff, right? That's more like age-old network configuration stuff. If you buy a domain name, you're going to be doing that anyways, kind of thing. So yeah, we covered Cloudflare, registering that. I guess DigitalOcean with that droplet of the VM, which is just a computer, so that's not too crazy. And let's see what else. Pretty much, I mean, this is just basically using the tools that we developed all the way through and putting them up in the cloud. Nginx, that was totally new with that configuration stuff. Yeah, I'll give you that. Well, I struggle with Nginx, so JC doesn't mind it, but I can't stand it. I'm so frustrated with it all the time. I've gotten to the point. It's just like, hey JC, we need to deploy Nginx. Go take care of it. But yeah. So, any other questions?
BJ, how long does it normally take when you talk about GitLab is free for the first 400 minutes now? How long does it normally take you to do this, to build a site then, like to deploy it?
Well, you saw ours 45 seconds. So,
So total.
you could do 800. You could do 800 pushes, I guess, to master in a month. Something like that. I don't know. 45 seconds? No, not 800. Like 600. Right. So that's is that what your question was, or is your question of how long does it actually take to set it up? Well, I guess 4 hours with teaching, so 2 hours, hour and a half, if it goes well.
But the build time is just that, how long it actually takes you to push it up, and that doesn't take very long then.
Yeah, I
Because
mean,
the actual minutes that you took couldn't have been more than about what, 15 or 20 minutes total during the 4 hours.
between like Netlify, oh yeah, the actual build, oh, I don't, yeah, we probably used 5 minutes, if that. Well, it only took 45 seconds and it failed early in that, so probably, yeah, for 3.5, 4 minutes on this initial. And, you know, if you get good at it, it's never a problem. I will say that, like, on some of our more complex systems, build times can be 11 minutes, 5 to 11 minutes. So you burn through those if you're doing that a lot. That's why you kind of want to conserve it. And you want to make sure that your stuff works before you deploy. Or often, sometimes, like when we're doing like database updates, because we haven't covered that, we'll talk a little bit about that next week. Because those are really frustrating. Those database, some of the database, like if you're applying an index to, you know, millions of rows, that can take on the order of 20 to 30 minutes or an hour to apply those indexes. At which point you're doing that manually. You're not running that through your CI/CD. So there's no point in spending build minutes on that. Plus, you want to watch it. I mean, you don't want to. That's a very I guess dangerous operation. So you kind of want to get your hands in there to watch it. So, and if you know that your build is going to take a long time for some reason, like you're building it from scratch, you're putting in a cache or something, you usually do that manually. So you just go through the steps. And then what JC and I will do is we'll look at the build scripts, right? And then we'll just copy and paste the stuff from the build scripts. So we know that it's doing the build, but we're just doing it manually because we don't want to spend our build minutes doing something that we know is going to take time. It's really just more of a call on that. But if it's like a simple like change like that, I mean, a minute, you're good to go. You save yourself a lot of time. And the biggest thing is you save yourself potentially messing something up accidentally. Because if you do it over and over, you know, you're going to make a mistake. So
BJ, now the deployment we did, the backend part of it, is it ready to extend to the extent that we can start provisioning?
yeah, you should be able to provision your vehicles and stuff against it. Yep, you can run the client. Just make sure to change the URL that you're hitting against.
Yeah.
And
okay.
Yep, api.fullstacksc.com, and you should be able to provision new vehicles in there.
Or just
an alter script so that he's going to create users for each one of you in the database. So
I'm just about done sending everybody their credentials.
Nice.
You get some DMs from me right now.
You got that, yeah.
So you should be able to log in to the system. Hopefully, if you can't, it's up to you guys to fix it. Just because I'm tired, I don't want to deal with it. Tuesday we'll fix it if it's broken. Any other questions? I was looking forward to doing this deployment tonight because I like this. This stuff's pretty cool. If it works. And it worked this time, so we're good.
Anybody successfully log in?
Yeah, I logged in.
Nice. Sweet.
All right.
All right.
So now it's just a matter of updating the Python client and loading up some vehicles into your account with your credentials. At the time being, and that'll be an interesting one for the if somebody wants to update the back end, is at the moment you're going to see everybody's vehicles when you go to log in. So we'll have to update it such that you only see the vehicles that you added.
Maybe we'll do that on Tuesday, JC.
Yeah, that's a quick add.
Really quick. We can also talk a little bit about data model alters on an update, because that's one thing we didn't talk about. What if your data model changes and you want to do CAC?
Yeah.
How do you manage that? Whew. That's still an open topic amongst the community. How to do that well. We'll talk about that. Cool. Any other questions? Cool.
There, I just added 3 vehicles under Lauren Mipsum's account, but everybody should see them at the moment if you log in.
Nice.
Yeah, I see that.
Sweet. How cool is that? I guess I know I'm in the right field because I'm just geeking out on something simple like this. Anyone else geeking out like this? I mean, this is pretty cool, right, guys?
So have fun. Go think of some cars to put in, right?
It's actually way cool. That's actually really cool that you can do this.
Yeah, even if you're like, man, I don't want to do this ever again. Like, you have to respect just how awesome this the systems working together and everything, right? I mean, it's just so cool how it all comes together, and how much technology. I mean, if you just take a step back and think how much technology we as humans have developed to be able to do this, it's just amazing. It really is amazing. All right, guys. Well, as always, let us know if you have questions. I know week what?
It's still magic.
But you get here. It's good stuff. And if you really enjoyed tonight, or see like this is something you'd want to get into, I think this is a much lower hanging fruit to get into. If you're looking to like change a career, right? This I find that a lot of engineers excel in this area because this is more configuration, and it takes a real systems kind of thought process oriented to really attack this. So engineers tend to excel in DevOps. Um, Probably more so than in coding, because you have to love to code to really get into it, right? And it takes some time, to really get experience. But DevOps is somewhere that in QA that you can really start making a pretty big dent. And DevOps is a place you can enjoy. QA, that's a hit or miss kind of thing. QA is, you guys know, we have QA and standard stuff too. But yeah, with DevOps, like if you really got into this. It's a good area to start checking into. You can get a lot of certifications in this type of area and through AWS, GCP, stuff like that, to just kind of be aware of the tools that they use, and it's a pretty lucrative job. You can demand a pretty high salary if you're pretty good at this stuff in this area. And we always need DevOps people too, particularly when you talk about big data. I mean, the challenge is just massive when you're talking about massive scale sorts of stuff.
Vijay, if we have to practice this like deploying from the scratch as you did tonight. So as far as GitLab repo goes, we can create a copy of week 9 in our own GitLab account. All we would need is a Droplet separate account.
Yep.
Right? And the big part would be getting a domain, the DNS, right? That's something.
Yeah, you could do that. Domain names are what? Like, if you get a really obnoxious one, they're like $2 here.
Oh, okay. Yeah.
Your bigger cost, of course, is your DigitalOcean.
Okay.
But another thing, and I'll probably do it next week, is Heroku is a cool one that does all CI/CD for you. It's a little bit more limiting, but like it'll deploy your backend. So it's like the Netlify of backends. So
Got it. Okay.
Heroku, it's kind of cool. It's Salesforce. Salesforce started Heroku years ago. We use Heroku sometimes, and it's all free. Like that's you can get a pretty hefty stuff going for basically no money. So you can check that out too.
Okay.
They have their own little Git repos and stuff too. So yeah, now that you've seen it, you're probably like when you go and see other services and how they do it, you pretty much have covered all the concepts with this and kind of seen how it works. Now it's just learning the words and the different ways that they will do it, but the flows are all pretty much the same. All right, I think we're at time. Anybody else have a pressing question, or we'll call it a night? Cool. Well, we'll call it a night. Thanks, guys.
Thank you.
Yeah.
Good evening.
Thank you.
Good night.
Hi guys.
Have a good one.